Did it got connected? Or am I just seeing things? I guess it got connected. Hello. 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 Yeah, I'm seeing this. So let's start. This is day 3 of learning Rust by myself. And today I'll not be just using ChatGPT or whatnot. I'll also be following my Rust docs that are given. So I have opened my Rust docs here. So this is Rust by example. And we see this. These are all the examples we'll be learning. Not just today, we'll be learning it day after tomorrow and after that. We'll be following this because it seems more structured. Because what happened yesterday was on day one, it was correct. Like I was asking it, it was answering me, and we completed day one. And day one was fairly simple also. But on day two, there was some data structures. I know. Borrowers was something that I learned on day one, but then there got some data structures included like str and then string. String is a data structure and str is a data structure in itself. And we were referring to str by ampersand str. Ampersand str was taking some length for the str because the str by itself is unsized, so it was taking the length for that, and it was also storing the reference of str. That ampersand str was also storing the pointer towards that. So it was all messed up and complex because we got into some theoretical loop because I was not able to understand it and ChatGPT would not let me go forward. So I ended that day. So I started a new day and this is a day 3. So it is telling me that this is a execution day. I'm not your planner. Because yesterday what it did was we got into some proper theoretical, and we did not move forward one bit. We were just messed up totally. So now I instructed it to, that I'll be also using the Rust docs. Where is it? Yeah, that I'll be alongside chat, I'll be following the Rust by example module. If you don't know how to open this Rust by example, you can directly go either online and search for Rust docs, and it may give you some results like learn Rust. It's awesome. And there are 3 things. You can either read the book, you can check out Rust by example, or do Rustling course. So I'll check out Rust by example for you. And yeah, see this. We are online and seeing the same thing that we were seeing offline here. So it's nice. It's same. It's nice. You can either open online or offline. For offline folks, how to open it? It's simple. You just have to write Rust up and then doc. There is doc. Yeah, and then it will suggest you there is Rust by example. So just type that flag Rust by example. It will take it automatically, and yeah, it will open it in your browser. See, it got opened again. So I'll close one of them. Like I'll close this, and I'll close this online version too because I don't need it. I have the offline version and it's running fairly well. Here it is. So I'll be using this. You can use either online or offline. It's according to your. So we'll start by introduction. So first we'll read all this because printing and all that is fairly simple. And as we go into some complex modules where we can't understand it, we'll send ChatGPT that this is something that I don't understand. Please help me and whatnot. Is this good? Seems like. And this is our chat GPT. We'll just minimize it more. Hey, minimize, minimize, minimize. Yeah, it seems like we'll not be using it. It is also telling me that this is the execution day and whatnot. Execution protocol is we go in strict order. If yeah, yesterday was something that I should be learning if and then like conditions and then loops, but we got stuck into something that was like important. It's not unimportant, but for beginners it was fairly complex. Like on day two, I was learning all this and it became mind-boggling for me. But I have some background with C, so it was not that hard to, but it was hard. It was very hard. C is totally different. It doesn't have much of a like data types. It has integer, then character. It does not even have a string. And in Rust, you get multiple things for string, str, then capital string. So string. There's multiple things. I think that Rust is fairly complex than C. So if you don't have a C major or something like that, just use Rust because it'll be fairly easy for you. Not easy in easy way, but like you won't have a benchmark to compare against. So it'll be easy anyways because people who were learning C earlier in days were telling everybody that pointers is hard, C is complex. And after the Rust came, yeah, now Rust is hard. So just follow the Rust and forget about everything else. Now we shall start. So we'll read this Rust by example, and let me check something else too. See, I'm quite new to this stream, and I was setting up OBS. It also took my some time. Oh, I can see that I'm live, I guess. Yeah, I am live. Going live is also exciting because it's something you learn. And I guess it is using WebSocket. So I was before doing all these things, I was into WebSockets and I was trying to implement WebSocket by myself using just WS library. Uh, I am live and seeing something like OBS using WebSocket and making it stream. It's nice. Yeah, I can see myself. I am live. So we'll start Rust by example, and shall we do this? Yeah. So Rust by example, Rust is a modern system programming language. Yeah, Rust is modern because C was so primitive that it didn't even have something called string. We had to define string and then use it, or we could just play with characters, charts, or cars. Chars is better. Char sounds better. But yeah, there was characters, and we could somehow manipulate it because character makes string. Character is like alphabet, and string is like sentence or word. So we could use that, but let's not compare it with C because you will have then benchmark to compare that Rust is hard or Rust is easy. But if it comes to data structures, Rust has also very predetermined data structures, and it tries to avoid what C cannot because C was so primitive it didn't have an idea. But what it did in the programming language world was awesome. But Rust is a waste of time in initial days, but after learning it, it's awesome. It's awesome than C. Rust doesn't have garbage collector. We'll see. I think It'll explain something like that. So Rust is a modern system programming language focusing on safety. Safety, yeah. C doesn't focus on safety, but we'll see Rust before compiling. It throws so many damn errors that yeah, we know it is safe, or it damn better be safe because it's showing so many errors while compiling even a single stupid stuff. Like yeah, and it's speedy because it deals in low level, language. It can be considered as a low level language, but it is fairly modern. And the concurrency is running two three threads at the same time, something like that. Parallelly concurrency. It accomplishes these goals by being memory safe. Memory safe is like you don't go out of memory, you don't free something that you don't have already. You go by borrowing and ownership. This is something fairly new in Rust that I understood on day two and day one. Day one was something I learned about borrowing, and then in day two it was all over the stuff. I know. So it got confusing with ChatGPT. So don't use just chat models. Take something for like documentations or official documentation, and then start following it with the ChatGPT. It'll fairly make things simple. Now, memory safe without using garbage collector. So it is telling me it doesn't have garbage collection that we already know. That's why we came to Rust. So Rust by example or RB is collection of runnable example. So these documentations have runnable examples. We can use them or we can manipulate them and try to do stuff. So runnable example that illustrate various Rust concepts and standard libraries. To get even more out of these examples, don't forget to install Rust locally. How can you install Rust? Just ask the ChatGPT or use, Cargo, or what did I use? I used Rustup because I use Arch, so I just installed Rustup. So yeah, and check out the official docs. Yeah, we will. Additionally, for the curious, you can also check out the source code for this site. Now let's begin. So hello world is the first program we'll learn. Then about primitives. So learn about signed integers, unsigned integers, and other primitives. So I don't know about signed and unsigned, but as for integers, it is you know integer, like in maths. So there is natural number, there is whole number, and then there is integer. Natural number is 1 to infinity. Whole number is 0 to infinity. It includes 0 plus natural number. So, and the integer is whole number plus the negative numbers. So it is from negative infinity to positive infinity. It's simple maths, yeah, of basic maths, I guess, 6 standard or 5 standard. Now, custom types are there like struct and enum. So we can, I guess, construct, custom types like in C. The struct was there in C too. As for enum, I never used it, so I don't know. Now, variable bindings. So mutable bindings, scope, shadowing are all there. We'll learn it. Like we can click and learn it, but we'll go through with hello world. Let us see what is all this about. Now there is type, there is conversion, there is expression. So expression, I guess, is if else. No, flow control is if else. So there is flow control. Then we'll learn about making function. Then there is modules. We'll organize code using modules. Then there is crates. Crates is something Rust have because I have never heard of crate somewhere else. So crate is compilation unit in Rust. Yeah, learn to create a library. Then there is Cargo. Cargo is something that is like manager of Rust. What it does is it organizes module, it organizes packages. You can run all the different, .rs files using Rust. You can also use Rust C to run a single file, but who uses Rust C manually? We will use Rust C if we are making a fairly simple program like print hello world. We'll be using Rust C, but Cargo is something you should use while making, official Rust packages because it is a management tool. And attributes, there is attributes is metadata applied to some modules, crate or item. We don't know crate, so we'll learn later. What is generic? So generic, learning about writing a function or data type which can work for multiple types of argument. Okay. Now scoping rule, scope is like two brackets, and inside that there is scope. Outside that, the scope vanishes. It gets dropped. So it's like see scope again. In Python, there is no scope, I guess. There is scope. There is no scope. No, there is no scope. Now traits. A trait is collection of methods defined by unknown type self. Macros are way of writing code that writes other code, which is known as meta programming. Okay. Macros are way of writing code that writes other. Oh, macros like print ln exclamation mark or something with exclamation mark is considered a macro in Rust. We'll use print ln, and I asked by this chat GPT and it told me it is a macro too. Now error handling. So learn Rust way of handling failures. Important. Now standard library types, standard miscellaneous, now testing, and then unsafe operations. We'll learn about a block of unsafe operations too. Now compatibility, handling Rust's evaluation and potential compatibility issues, and then meta. We'll have documentation, benchmark, and whatnot. So we'll go with hello world. Stop wasting our time. Hello world. Now we got a hello world. So this is the source code of traditional hello world program. So this is comment. So double slash, it's like C. You can write double slash or you can use this for multi-line comment. Hey, this is a multi-line comment. This is a multi-line comment. You know, instead of doing this forward slash slash again, you just do this. I prefer doing this. It's easier. You can write multiple program. And then this is the main function. Main function is something in binary, it is sort of starter. So in binary, there is all 1 0 where you start is something called starter. So this is important, like in C, because program starts from here. It starts reading line by line. And if there is a mention of another function, it goes to another function. So main is something important. So this is a comment, it is ignored. You can test this code by clicking the run button over there. All right. Or if you prefer to use your keyboard, you can use Control Enter. All right, Control Enter. I guess it will work. Yeah, yeah, it's running. This code is editable. Feel free to hack it. Yeah, like do something that it should not do in Rust, like writing print instead of print ln, or writing print f, like in C. Will it do it? Will it do it? Will it do it? Will it do it? No, it doesn't. So it throws a compiling playground error. So it's like src main.rs printf not found in the scope. You may have meant print macro. Oh, there is print macro. Let's do it. Print macro. Oh, there is print macro. Hello world. There's print macro, then print ln. What are the differences of print macro? Because I have everywhere seen just print ln, not using just print. It's awesome, I guess. What if we used it without exclamation marks? Oh, oh, so print is not a function. I'll use exclamation to invoke a macro. So yeah, yeah, exclamation to invoke a macro. So print is also a macro. This is something new to me in Rust. So for more information, try Rust C explain error. So you can use Rust C because yeah, it has something called explain, and then it tells you what error to search about, and I can search it. Error could not compile playground, bin playground due to one previous error. All right, we'll just use print ln. I don't know if it's standard or something like that, but we'll use that. So there is a main function here and statements are to be executed, and this is print ln. Now I've seen certain examples, like I went through these documentations just few minutes ago, and I saw some examples like this. Is this right? No. Yeah. And then if we pass some variable sort of x is equals to 5, what it shall do is error, or 5. It prints 5. If I mentioned a y, then it should throw errors, something like that. Yeah, it is error. If we pass x, it should 5. So I I got flashbacks of Python, where we used just f after that, and in the string we typed all this, but it is also mixed with C. So sort of it has to be explained with comma here. What if we don't? What if we just explain C somewhere, like explain this X somewhere else? है ना? Like cut it. How to open a new line here? It does not use. Sorry. So it does not use. in- I hoped so that it used it. Let's see. Let what is X is mutable or immutable? It is immutable. So if we are defining a variable, it is immutable by default. And if we want it to be mutable, we have to write mut, mute. So sort of that, and is equals to, let's say, 5. Will it print the 5 automatically, or will we have to define comma X? There is compilation error. So in a macro, you have to pass, you need a variable here, and after that, you have to pass that variable. It should print right now. It didn't. Wow. So what it's telling me is let mut help add. Sorry. Shit, damn it. Mm-hmm. It will throw an error. It didn't. Oh, fuck. It did. It did. Thank you. What if we just passed X? That, yeah, just print X. Will it pass? Will it pass? Will it pass? Will it pass? Timeout. So it will not pass, I guess. So println is a macro that prints text to the console. Text. Yeah. So timeouts. So I guess we should not be using this. We can use this X, and then we can create another variable Y just here only. Y is equals to 2. Will it print? Because X is defined here and Y we are defining here, but we are not mentioning Y. So let us mention Y. Will it print? I don't know why it's timing out. All right, let's not move ahead of this documentation. Let's follow now. So this was this documentation, and we printed hello world, and it should have worked. Should we reload it? Yeah. Something's happening. Something's gone wrong, I guess. Don't worry, we'll just make a new hello.rs or something like that using Rust C. No, Rust C is to compile. We'll use NewVim to create something here, and we can then move forward. But yeah, we can understand what println does because we have seen what println does. And now we go to this instruction that println is a macro that prints text to the console, and then a binary can be generated using Rust compiler, that is Rust C. So even when we pass through cargo, that cargo run this, cargo build this, then it uses Rust C to do that because Rust C is the compiler. Cargo is just sort of manager or builder, so not builder, manager. It manages every packages, everything, every sort of stuff. So Rust C will produce a hello binary. Yeah, what it does is just remove this .rs and names the compile binary the name of the file. C did not do that by default. We had to sort of mention that dash o use a flag output, uh, then mention the name what we wanted it to. Otherwise, it would just output a dot out or just a dot out. Yeah, we have to mention dash o, but Rust does it by default. Rust will give us a hello you know, executable. And when we run this, running this is like this. We run this. So why not just copy it? We'll copy it, and then and vim hello.rs. I don't use these complex. I just use 1.rs, 2.rs. It's fairly simple, and I'm quite lazy while learning. And there is only hello.rs here. But as soon as we do something like rust c hello.rs, it gives us a hello. Let's see what is it. It's ls, and there is a hello program. So we can just directly, execute. This is execution. So this thing, this is mentioning that, this is the file. This is current directory. This signifies this is current directory. Like, why I say this? Because when I say cd and this means current directory, it will just not change our directory. We are in the same directory. But if we say cd and we say add two dots, this goes back to our previous directory. So this is previous directory. So yeah, that's why we'll just use cd. We can check day 3, 0, 0, 3. So we are back, and in this we can specify it by for running it, because it is already executable. So when we type lsl and everything, we are seeing that hello is a executable. We are seeing the x is executable, r is read, w is write. So we see executable. It is executable by default in everywhere. Everywhere it is executable, whereas this is not. So we know this thing is executable, and we can now just execute it by telling it this is the folder, this is the directory we are using, and the name of the program we will be executing, and we got a hello world. I guess this is clear to all of us, and we'll move forward. So activity, run the above C expected, add a new line with second println macro that outputs hello world, I am rustations. I am rustation. So let's copy it. Oh, and we'll print here only. Or if it doesn't this time also, we'll just go back to our, making our own program. Control enter. It is not even using control enter now. Yeah, it did print. So hello, I'm Rustation. We got the output. So we can move forward, I guess. So comments. So yeah, this is the multi-line comment. This is single line comment. That's like C only. So any program requires comment, and Rust supports a few different varieties, like regular comment, which are ignored by compilers. Yeah, comments are ignored by compilers. So this is a line which goes to end of the line. Line comments which go to the end of the line, and block comments which go to the closing delimiter. Then docs comment which are passed into HTML library documentations. This is a different type of generate library docs for following items. And this, so yeah, there is a cargo, and we can generate sort of, cargo, and then there is, I read it somewhere. No, I did it here only. Clean fetch doc. So I guess this creates the doc or document of the whole program that we wrote. So yeah, if we want to specify something in comment that we want to see in HTML library documentations, we shall be using this, but we will not. Who focuses on making a doc? So generate library docs for following items, and this generate library docs for the enclosing items. All right, we got the point. So this is function main. This is a starter, and now this is an example of line comment. Nice example. There are two slashes at the beginning of the line, yeah, and nothing written after these will be read by compiler, yeah. and in the next line, whatever we write, it will be read by the compiler. So don't do it. Now println hello world. We have this commented out this, so it will not run. Run it and see, and now try deleting two slashes and run it again. Yeah, we know it will not print anything. We know it, but let's do it. Oh, there's a program, so it will run something like this. All right. Now this is multi-line comment. Now this is another type of comment, a block comment. In general, line comments are recommended comment style, but block comment are extremely useful temporarily disabling chunks of code. This block comment can be, nested. So it takes only a few keystrokes to comment out everything in this main functions. So try it out yourself. We did. If you want, you can. Now note, the previous column of this star was entirely for style. These stars are just entirely for style. You can just remove them. Yeah, we did also. We did that too, yeah. So there no need for styling. But if you want some styling, you can. Now here's another powerful use of block comment. You can uncomment and comment a whole block by simply adding or removing a single character. So add another before list uncomment the whole. Oh, so it is telling me that if I do this, then it will become a single line comment, and now we have unblocked these lines of code. Wow. Yeah, yeah, I knew it, but I never did this, so seems amazing. Now, before the first one to uncomment the whole block, so it'll uncomment the whole block, and then line comments inside are not affected by either state. Yeah, line comments are line comments. They are not affected at all because they are just for line. And we have nested this into line comments, so that's why it worked. Yeah. What if it was not happen? So we are seeing it being alone, and it will throw an error that there is something this unknown because it does not have a pair of this. So we see that color changes as soon as we remove this. It becomes sort of executable, which you don't want it to be. Now you can manipulate expressions more easily with block comments. Yeah, then with line comments. Try deleting a comment delimiter to change the result. We can change the result by deleting this. Let's see. What should it print is, so there is x and then plus 5. So x plus 5 is 10. So is x 10 or 100? So this is 10, and if we add 90 to it, it will become 100. But timeout here. I guess we shouldn't be wasting our time on this. You can either directly copy paste. It will work fairly simply. And instead of using hello or any sort of other names, I'll just use 1, 2, 3, 4, 5, 6. It's my sort of box. I know hello. This is our comment. So if we execute it, we shall see now everything executes, and then these ls. Shall we remove hello.rs? Yeah, I will. Hello and then hello.rs. Now there is Rust C 1.rs. We use Rust C because we are not making some modules and managing everything. We are just making fairly simple programs. Just run and see the result. So X is 10 or 100. It's 10 because we did not uncomment our where is nvim? We did not uncomment this 90, but if we do that, it will be 100, as we all know. Rust C and then one. Yeah, it's 100 now. So I guess we can move on. Now formatted print. So print is handled by series of macros defined in standard FMT. It's sort of library, I guess. Like in C, it was sort of hashtag include stdio.h, है ना? Standard input output.h. So this is standard. Now FMT is, I don't know, but just standard library, some of which are format. So format is also a macro. We write formatted text to string. We'll try using it. Will it run? First of all, let's see. It throws playground error. And then we can use print. Yeah, we did use print. And same as format, but the text is printed to the console. So formatted text to string. So we can use format to format the whole variable or string that's assigned to some variable. And print, it prints same as format, but the text is printed to the console. So it is input output thing. So it inputs something, it outputs something. So std out. Now print ln is same as print, but a new line is appended. Oh, so there is backslash n automatically. Backslash n is sort of escape character. Backslash n, not forward slash, backslash n. And eprint is same as print, but the text is printed to a standard error. So if we want to print some error, we do this. Andeprintln same as eprint, but new line is appended. All right, so we got the point. Now all right, I guess there is some error. 37, line 37. Where is line 37? Yeah, so it is throwing an error here. Fix me, add missing arguments, James. All right, we'll come to that. Now there is main function. In general, the brackets will automatically replace with any arguments. These will be stringified. So yeah, this shall print 31 days. All right. So we know this. It shall print 31 days. We remove the comment here. It's making it bulky and now, positional argument can be used specifying integer inside brackets, determines which additional argument will be replaced. Argument starts at 0 immediately after the format string. Now, println b, println 0, this is 1, and 1, this is 0. So Alice and Bob. So Alice is 0, Bob is 1. So Alice, this is Bob, and then Bob, this is Alice. I guess this will be output. Shall we print it out? Use this. And at the end. What if we run it? Please. Playground timer. So we'll copy it in new vim, we'll paste it and see what it does. Now let's clear it, shall we? And vim 2.rs. So this shall print on 31 days. And then this will print Alice, this is Bob, and Bob, this is Alice. Alice is 0, Bob is 1. Now let's see what it does. Rust C and 2.rs. We got, yeah, it got compiled, so no error. Now we got first as 31 days, and then Alice, this is Bob, Bob, this is Alice. exactly like we interpreted it. So yeah, now we'll remove all this. So this is, I guess, 6. So as the name argument, as can named argument. So these are named arguments. So subject bracket will print the subject. So the quick brown fox, and then verb will print the verb, which is jump over, and then object will print the object, which is the lazy dog. Can we see it? Yeah, we shall. Oh damn it. I was not in the insert mode. So let's go into insert. Insert this. It's commented, and then try printing it out. The quick brown fox jumps over the lazy dog. Yeah, this is what we expected. Uh, Subject was the quick brown fox, verb was jumps over, and object was lazy dog. So it prints out. We understood it. Now we shall delete it. Now we got after A, whatever this is. Let us understand. What is this? So print element. So base is 10, and then there is this for this variable. So base 10, and then this will print 69420. And then there's base 2 binary. So I guess this will make the whole variable, this thing will make the whole variable, binary. So this will get converted into binary, and we'll see this output. That's why I'm telling you. And then there is base 8, which is octal. So we are referring it to O. So this is sort of a flag which converts our variable or whatever number we are passing into this format. And I have a doubt. What if we type character? Will the character also get converted into binary, octal, hexadecimal? Well, it should, but we will not do that. We know that this will convert into this. We can use a program which convert this number into binary, this into octal, and this into hexadecimal, and it will print it. So if we used format, it will just return something. It will not print it. And if we use print, not print ln, it will not add a backslash n. So I guess print ln is something looking like this. L is looking like backslash. Uh, am I insert? Yeah, am I insert? So this looks like backslash and then n. So yeah, now I get the point of why print ln, because print is print and then backslash n. So instead of writing backslash, we wrote l. So it looks like a syntax to me, and now it does make sense. And this exclamation mark is, this exclamation mark was used for, exclamation was used for uh, telling us that this is a macro, or telling this compiler this is a macro. Now we shall see all these outputs, with these formatted string before them. So let's compile it again and see the output. So base is this, and the binary of this base is this, and then octal number is this, and then hexadecimal is this. It shall start with 0x. That's the format of writing out hexadecimal. But yeah, this is the main thing. This is the number. 0x just signifies. So if we write 0x, where is 0? 0x, or is it OX? I don't know. 10F2C. So now this becomes a proper hexadecimal formatted number. Is there a program that converts hex to? I've never used it. Hex to HCD. What it does is, let us see. Bluetooth firmware coming. Oh, what about hex dump? What it does? Hex dump. So it displays file contents in hexadecimal. So 1 byte octal, 1 byte hex, format file length, no such thing. So I don't know how to use this, but yeah, yeah, we can use it to convert sort of. I guess, but let's not use it. We were on this. Let's try it, shall we? X dump. This is Linux, so it will have a program, but no such file or directory. So it, I guess, works on file only. All inputs are all input file argument failed. What if we say this is input invalid? So we don't know how to use this. All right. We will not use it. This is fairly complex. Now we'll go to our, you know, tool.rs again and shall see what is doing next. So we understood that it prints, this is a flag, this colon and X. It will convert our number into, hexadecimal. This will convert it into octal. This will convert it into binary, and I don't know how to reverse it. So if we have a hexadecimal, can we just get a base number out of it, and how? So we can ask ChatGPT this after, learning first of all basic stuff. So shall we delete it? How many lines? 5 lines. 5, delete. Now if we delete it. So you can write justify the text with specified width. This will output uh, the number for white space, 4 white space. So we'll get 4 white space and then the number and a 1. So for total width of 5. So we are defining total width of 5 as this, this colon and then greater than 5. And this is number. So number is the variable. It will print 1, but in this format. So this is sort of formatting. We can understand it like it is greater than 5. So we'll get total 5 of width, out of which 1 will be the number itself. If the number got 10, will we get 6 or will we just get 5? Insert. Oh, just see u.rs. 10.0.0.1. What is this? Yeah. It is what we expected. So I don't know if we have 4 or 3. 1, 2, 3, 4, 5. Yeah. It is, 3 byte spaces and 2 is characters of our numbers. So it is giving us total width of 5. So, and out of 5, 2 gets utilized by our variable, that is 10. If we just used 1, like 1, then we will get a 4 byte space and 1 as a width for this variable. So it will total to 5. Now you can pad with extra zeros. What does that mean? Oh, so for all the white spaces that we are not seeing, we can just pad it with zeros. So this is the format for that. Instead of using nothing as a white space, we can use 0 as the white space indicator that there exists a white space, and then number is the 1 only. And it is saying we can left adjust It's not left adjusting it, it's adjusting the whole number. It is no longer 1, it is now 0, 0, 0. So left adjust by flipping the sign. This will output, well, it is 10,000. So yeah, that's why we got all these. Now you can use named arguments in format specifier by appending dollar. So what is named argument? So yeah, it is telling me that I will get number as 1, and then before that we will have 0, and then width will be 5. Oh, oh, oh. So instead of directly writing or hard coding the 5 inside this, we are now taking a variable named width, and we can change it from here, or we can just define this variable outside also. Shall we do that? Let's try for at least one of them. Yeah. So insert mode. Yeah, I'm in insert mode. So let width is equals to 5. It shall work, I guess. If it doesn't, we'll come back to it. It does compile. So yeah, it does work. It is same output. We are getting the same output. So yeah, it does work. And instead of writing these number one again and again, we can sort of, don't comment it, we can just use a variable called number, and that is equal to 1, and I guess we will just use it instead of writing it here. And I am guessing that it will work. It will give us the same output that we got for the last 2 times. Will be. Escape. Yeah, it's all done. Will it compile? Will it come? Yeah, it compiled. Have it. Yeah, yeah, we did it. We have the same output. So yes, it works. It works, guys. It works. So we now understood what println is. Huh? This will give us a width of 5, like white spaces. This will give us a width of 5. That number is 1, so we'll get 4 zeros before that. But it will be using 0 for the white space instead of using space. And we'll get a width of 5, but instead getting white space or zeros before the number 1, we get it after the number. It's bad, but somehow it makes sense to do this. And instead of writing directly hard coding it as a 5, we can just write 5 over here and use it with a dollar, and it will give us the same result as this one. That's what we are getting for the past 2 times. Yeah, the second and fourth result are the same. Yes. So we will delete everything. How many lines? 12 lines. Now we have this. Rust even checks to make sure the correct number of arguments are used. So my name is 0, that is Bond, and then there is another argument that is 1. So we shall have a index 1 here. That's why it says fix me, and it is telling me to add a missing argument James. So we will add James to it. Oh, sorry, it is a string. Damn it. I am pressing end, but it gives me this select. I don't know why. Why is it doing this? Why is it doing this to me? So I guess we'll get my name is Bond with James. Where is the compile? Rust. See. Oh, expected. Yeah, we did not comment everything out except that. Yeah, we shall use it. Insert mode, and it will say my name is James, and then comma, then Bond. No, no, no. It will say my name is Bond, comma James Bond. So it will say my name is Bond, James Bond. Very cinematic. Let's see this. Yeah, it compiled, and my name is Bond, James Bond. You got the result. Now we'll delete it. We fixed it, and now only types that are important. Now only types that implement FMT. What is this? I don't know. Display can be formatted. So FMT is format. Display can be formatted with brackets. User defined types do not implement FMT display by default. So hashtag allow dead code. Disable dead code with, okay, so this is our next thing. So how many lines? 6 lines to delete. So we are to the last part. So we are allowing dead code. Disable dead code which warns against unused modules. Make me understand what is this. So we are defining a structure called structure, which takes an input of I32, which is integer 32, which means it is taking an integer 32 bit, which has 4 byte. So what will it do? We are just defining the structure called structure, like we used to define string as pointers of character. So what's telling me is this will not compile structure. This will not compile because structure does not implement. And FMT display print ln, try and commenting this line. This struct won't print structure 3. It shouldn't print. We should comment this out. These lines are something else. We shall see. Did it define structure I32? And when we are passing structure with a number that is integer inside 32-bit, which is 3, this struct, and here the 3 should come, but won't print because this is somehow dead code and will warn against some unused modules. So let's see what it does. We'll see some errors right now. Yeah, we got an error. It's telling me structure doesn't implement standard formatting display in 2.rs 749 character. We are getting required by formatting parameters, and structure cannot be formatted with default formatter. All right. And then we are getting the trait standard FMT display is not implemented for structure. Then it is underlying into, structure I32. Note, in format string, you may be able to use this or this for pretty print instead. In format string, you may use this. I've never used it, but we will use it. Format string is something, I guess, like println. Then there is format ln or format, and there is print. These are all macros. Now this error originates in macro. Yeah, crate. Now we don't understand what a crate is. Format arguments ngl. Nee, nl. ngl is not going to lie, but nl, which comes from expansion of macro println in nightly build. Run with backtrace for more info. Aborting. Shall we try this? What will it do? Let's see. Oh, it gave me a less file. If you understand what less is just a program that makes it such that you can toggle between using JK like Vim or arrow keys, I guess. arrow keys. Yeah, arrow keys work. Or you can just go to line number one or line number three, line number like that. This is a less program, I guess. And it is showing me that trait foo. Foo is sort of, foo assumption. Now the fn bar ampersand self, it is taking a reference of self, which is immutable. We implement the trait of I32 type, like implement IMPL, foo for I32, and fn bar, which is taking a self. I don't know what it means, but fn some function, then t slash foo is type of t, and foo dot bar, we are trying to make a function, I guess. We can now use this method since I32 implements the food rate. All right. Oh, I32 implements the food rate. And then there is fn main. We now call the method with I30 type which doesn't implement the food rate. Some function which doesn't implement the food rate, like 5 I32 errors, rate bound I32. Foo is not satisfied. Is foo defined, or we are defining it like foo, like something else? I don't. In order to fix this error, verify that the type you're using does implement the trait. Example, trait foo, fn bar itself, we implement the trait on either two. These are something that we have no idea about right now. To quit this, you just type q and it quits. Yeah, I guess we will see these errors some other times. For now, we know that this will not print, this will have some error because there's, this I32 that is not satisfying the FMT whatever. So this structure won't print. We did try to print it, and now we shall delete it. Yeah, we did. Now for Rust 1,58, it's a version, I guess, 1.58, 1.58 and above. You can directly capture the argument from surrounding variable just like above. This will output 4 white space and a 1. Oh, so we implemented this. Remember, we did it. But now, what is this? This is colon, and this is telling that it is a type of F64. So it is float 64, and it is telling me this is a uniform sized or U size. What is U size? There is unsized, which is for str. This is U size. Well, I don't know. But now this is the same thing. It will have a number which is 1.0, and then there will be a white space of width that is 5. So let's see. Uh, Array, yeah. There's no need for this, so we'll just delete it now. It compiled. See the output. We got 1 with how many white spaces? 1, 2, 3. Oh, damn it. Yeah, it says 4 white spaces, so we'll take that. So it's like a tab. 1, 2, 3. Damn it. This is 3, this is 4, and this is 5. Yeah, we have a 5 width of 5. Yeah, we have width of 5 and 1.0 not seen because it is printing as a number. It is float, but it's printing as a number. So now we shall delete everything. Now we will just paste everything such that we understood what it says. Yeah, done. 2.rss done. Now we'll remove all the binaries, all the compiled thing. 1 and 2. I guess we understood all these things, and playground communication was timing out. So I don't think we need it anymore. It was better because we could, edit fast and new them. We were just using mouse and all. Now, standard FMT contains many traits. Now it is explaining me something about standard FMT. If I press this, I will go to standard FMT. I don't want to. I just want to follow this. Contains many traits. Now trait is something else, which governs the display of text. The base of two important ones are listed below. So FMT debug uses this question mark after colon marker. Format text for debugging purposes. So for debugging purposes, we shall use this, colon and question mark. And for display, uses this. Yeah, we used it. It displays number or variable, whatever it is. Marker. Format text in more elegant and user-friendly fashion. Oh, come on. Have you used FMT display? Yeah, because standard library provides implementation for these types. To print text for custom types, more steps are required. Implement FMT display trait automatically implements toString traits, which allows us to convert the type to string. So there is an implementation to string and which converts to this is a data structure, I guess, which is string, capital S, string. In line 43, let's see what is line 43. In line 43 here, in line 43, allowed dead code is an attribute which only applies to the module after it. In line 43, allowed dead code is an attribute. What is attribute? Damn it. Since this is Rust by example, we will get some things that we don't understand, but we will understand it in future. For now, we will just read it through. That line 43, which is allow dead code, is an attribute. So it is an attribute which only applies to the module after it. Now activities, fix the issue in the above code, see fix me so that it runs without error. We did it. We did it. We added the bond or, you know, James somewhere here. Where is that? Remove this. Yeah, James. We added James and it worked. J-A-M, yes, James. And we fixed it. Then second thing is try uncommenting the line that attempts to format structure. We did this too. We tried printing it and we got an error. And add a println macro that prints pi is roughly 3.1. So we have to do this now. Roughly 3.14, controlling the number of the decimal places shown. For purposes of this exercise, use let pi is equals to, this is a variable pi we will be defining in the main, and as an estimate for pi. Hint, you may need to check standard FMT documentation for setting numbers of decimal places to display. We will check it out later in life, not now. Or we'll just come in through. I don't know. We should try. This is long, but we just want to, control the decimal places. So if we see something like that, oh, this is done too much. Format is format, formats, stations. Yeah, I did see this. Important. I read it through, and then there is toString, which was attribute or implementation, I guess. IMPL. Now position formatters, it formats the position. Now named parameters, identifier, then this is expression. Or does arguments take the argument test and prints it out? This is name. This takes the name of two. It is two. And what is this? This is one. So it'll print 2 comma 1. Like 2 1. This is A B C. It will take A as A, B as B, and C as 3. So it will print A3B. A3B. Now let argument 2 plus 2. Format argument. Argument first of all stores after doing the arithmetic and then directly shows the output 4. Now first of all, let's not forget that we want to implement something. So we will, since it's a part of new activity 2.rs, so we'll create 2 underscore 1.rs. And what we want to do is fn first. Oh, sorry, insert mode. Then, yeah, we'll define a function called main. It won't. Array, yeah, this end thing is making me mad. Now we got a let pi is equals to this, then semicolon, and we somehow want to use print ln to print this pi. Can we write value value of pi? We will do whatever we understood for now and just try using a knowledge for now. First C 2 underscore 1 rs. Yeah, it got compiled. Why shouldn't it? And to this value of pi is this, whatever our variable was. And now we want to control, let's say we want to just display 3.14. So instead of changing our variable to 3.14, we shall do some operations with print ln, which is the macro. How to do this? If we do something like this is not an error, but what if we do this? What will we get? Error? What will we get? Nothing. Nothing happens. All right. We want sort of, what about width? What if we start adding width of just 3? What will happen then? Compiled. Nothing happened. Oh, it doesn't work. What we can also do is, like, this is a pi. If we want just for, standard purpose, it is a type of F64. And this defines that this is a float of 64 bytes inside 64 bytes, not of 64 bytes, inside 64 bytes. It is represented using 64 bytes, so it uses 64 bytes, but not totally. Oh, how can we just do 3.14? Let's do something that doesn't make sense. No. Doesn't work. How about dot 3? It did come again. Oh, we did it. We did it. Oh, it is also even estimating it. Like if it is 5 or greater than 5, then it is converting this 1 into 2. And if it is, well, what shall we say? Since this is 1, we will be estimating it to 3.14, not 15. So now let us, instead of doing 3, let's do 2 and we'll get 3.14. Replace this with 2 and we shall get what we want. Yes, we got our result. I'm excited. I am flabbergasted. It worked without reading this documentations. uh, let's go through it very fast, very fast. So this is let a is equals to 5. Then b, we are taking the reference of a, not the a as argument. We are taking a reference. This is ampersand reference. Now we are trying to print a and then e. Oh, e is for, I guess, hexadecimal. E was for x for hexadecimal, b for binary, o for octal. What is e? E for what? E for what? What is e used for? I guess this is what e is used for. Exponential. So 5 as a power of 0, I guess. 5 raised to the power 0 becomes 1 now. So E0 means, I guess, 1. So that 5 raised to power 1 is 5. So we are getting 5E0 because we had 5. And B also has something. What B stores is a pointer pointing towards A, which is using the 5. So therefore B prints the pointer. So we are using this colon and then P, which prints the pointer. So this is the address of the pointer, I guess. Let's read this. No, we should not. Right now, we don't want to get stuck in all these theory. So print ln, so hello, and then we have a colon and 5. What it does? It does nothing. What does it do? Shall we see? Hello, and then 5 for my x. Oh, there is a run button. It doesn't run. Or will it go online? Oh, it goes online. All right. Trust playground. Oh, run it, run it, run it. So, okay, we got 5 white spaces. Well, we got 5 white spaces after writing X. And then what is this? Hello, and this is colon 1 and then dollar. Okay, so 1 is an argument that this is 1, this is 0, and this is 1. So we got an argument 1, past argument 1. So this is 5 because $1 means this place over here. So $1 is 5. So this is also giving us a white space of 5 characters and also printing the X. Now this hello and 1, which is X. So now instead of writing X here, we wrote it over here. So this is 0, this is X. Like think it like the index of an array. So 0, it starts with 0 and goes to length minus 1. So yes, it is 0 and this is 1. So we are printing 1 first and then we are giving it a width of 0, which is 5. है ना? $0. So $0 takes the what do we say, input of this 5 and places it over here. It becomes something like this and it prints the same thing, same damn thing. Now hello, and then we are defining things properly, that this is a width, and dollar. Now we are explaining what width is and giving it a value, and we are using again 5 over here, and x gets printed as x because it is a, I guess, text. X is not a variable over here. X is just a, well, since we use double quotes, is it a character or a string? Well, X is singular, so it shall be character, but I don't know if it's string or not. String uses a single, you know, quotations. Now, instead of writing width over here, we did this, and we can also, just remove everything away. We can also do something like, for standard purposes, width is of type. What is type? I32. I guess it is an integer, and 32. Will it run? It shall run. It doesn't. Yeah, there is a width, expected U size. Oh. So width is a U size. Now we have to understand what U size F64 and I32 means. But for now, just do what it says. Width is of type U size. Yeah, it did run. So width is a size is a type of U size. What is U size? What is I32? We will know it in future, I guess. Now we ran it. Now this is assert equal fill alignment. Shall we go through this? I don't think so. I think we shall move on. Precision. Yeah. See, this is what we wanted earlier, that we want precision or the decimal values, zero point 0.5. It will give us a decimal value of five places. So it will go like 0, 1 and then 0, 0, 0 till it becomes precision with five decimal places. Same with all that. It is taking 2 as an argument. 0, 1 and 2. So this is taking this as an argument, and then this is taking width of $1, which is 5. And then, yeah, doing it. What does it do? What does it do? So what's the use of X here? X is here. So hello X is then whatever this is, 0.01, and then getting a width of 5, which is $1. All right, I got it. So we did fulfill our purposes. If anyone wants to read it thoroughly, you can go at this thing, this link, doc.rustlang.org standard FMT. Yeah, so I guess this works. Now we shall close it and move forward with our documentations. Remove it too. How many hours has it been? So we sort of fulfilled our sort of activity. Last one also. We got 3.14. What it wanted was add a println macro that roughly is 3.142. Yeah, just add instead of we got this argument, we got this result by doing zero point 0.3 instead of zero point 0.2. Here it's zero point 0.2, and we can just do 0 0.3, and we have done our due activity. It's done. Yeah, this is done. And standard FMT documentation, we found what we wanted to. And C also, it's also recommending us to go through standard FMT, then macros like print and print ln and format, everything which has exclamation marks to it. That's what I know for now. And then it's telling me to go through struct and then trait and dead code. Dead code seems nice. What is dead code? This was dead code, and this is simple also. So dead code, what was dead code? We will see that in Rust by examples also. We will now. Yeah, we will see this in 13th attribute chapter with dead code and crates and everything like that. Close it. On dead code, compiler provides dead code, which is lint. What is lint? That will warn us about unused function. An attribute can be used to disable the lint. Lint is sort of that squiggly lines that you get in your, IDEs. The function, used function, is like allow dead code is an attribute that disables the dead code. Then lint, allow dead code, unused function. Then noisy unused function, it says fix me, add an attribute to suppress the warning. I guess this is the attribute which suppresses the warning. Is an attribute that disables the dead code lint, and then this is main, which passes the used function. Yes, yes. And the main returns the value of, it returns the value of this. So I also learned this in our lecture one. It was something like it default returns this, and this is called unit type. So this is the value that gets returned, and it has a value of this. It has a value of this, and it is called unit type. So yeah, if you do not return anything, it will return this. Instead, if you want to return something, you can just write, let's say I want to return 0 instead of that, unit type or bracket. We can just do this. But if we say something like, oh, we missed a semicolon, then it will just become a statement instead of returning something. So if we want to return a last function, we'll just remove the semicolon, and it will become a return thing for the function. And if we want to specify a return with using a semicolon, we can just say return 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 0. Now, since this is a main function and we can't see much of it, I will try to just write another function that returns 0. So fn, which return return, I guess, 0. We'll make this function. It's a useless function that we'll just use it to show as an example. Return, yeah, this spelling mistake will take my life someday. Return 0. So what it does is, for now it returns. Let's remove this. We don't want to use used function. Let's just state a macro where first of all we let uh, r is equals to the value that gets returned by return 0, return 0. All right, and then what shall we do is try to print print ln macro again, and inside that, inside semicolon, inside quotes, we do say this, and then we try to return the r. What is the value of r? We missed semicolon, don't miss it, important. Shall we see something? Will we see something? Nah, it says cannot be formatted with default formatter required by this formatting parameter. Okay, it cannot be formatted because I guess it is returning unit type. And instead of returning unit type, let's say return 0 explicitly, not implicit, it's explicit. We are defining what we want to return right now. Will it return 0? And no. Expected one of the 8 possibility. So I guess we are facing some errors. We can just use ChatGPT for now, but we don't want to. Let's see error. Oh, we can't type question mark because as soon as we type this, we get help. Oh my damn. Shit. All right. I get the point that, every function just returns something like this. This is called unit type, and I guess it can't print for now. Hmm. Let's use ChatGPT for now. 2 minutes. It will take 2 minutes. Uh, our chat GPT is here. Before that, help me clarify this. So, I was trying to see the default return RETY and then try to change it, but there is some error. You expected default return behavior. Instead, you get a compile error. Yeah, I did. Let's break down the from first principle. All right. So fn return 0. It automatically returns this because you did not specify the type. Oh. So instead of, see, we used to specify types of function like this. So if it returns something like a number which is integer, so we'll write i32, but since i32 is a type for integer and this is a unit type in itself, we are returning unit type in itself. So yeah, we'll need this. So this was our first mistake. This is unit type. The function returns the unit type. It's not an integer type, it is not a float type, it is not a character or string type. This is a unit type. So this unit type represents no meaningful value, exactly one possible zero size type. This is valid. Step 2, what is R? R, I guess, is taking whatever this return 0 function is returning to it. So since the function returns this, the type of R is this, the unit value. So R holds the unit value. Why does this print ln, this thing fails? Because print ln with this requires the value to implement to standard format display. So does unit type implement display? No. So that is an error. So if R was equal to sort of 5 or 6, it will not show any error. But since it is trying to show this unit type, it will show an error. So this is error. The compiler is telling you that the trait display is not implemented for the unit type. Yeah, it ignores unit type. We don't see unit type. I haven't seen in the past 2 days. So how to print it? You must use debug formatting. So I can use it just by copying pasting, but I can't type, you know, question mark, because as soon as I press shift and then question mark, I get a help window from this, I don't know, website. So I guess this will print now. I was trying to do this, but let's do it now. Why? Because this implements debug, not display. Step 5, important concept: expressions versus statement. So yeah, this is a return statement. No, this is expression, I guess. An expression without debug returns the value. So this is an expression in itself, and it returns the value 5. And 5 is a type of integer, so we are defining that function as an integer type i32. The type of function, the return value of the function will be of type i32. That's what we are trying to say. But as soon as we type a semicolon over here, this expression becomes a statement and returns again this unit type by default. So unit type gets returned by default. If you have not returned anything, it will just return this unit type and will not be able to print it. And returns 5. This will return unit type. So now the last line statement returns unit type mismatch. This is critical for you. Deep rule. Oh, don't test me, all right? Don't test me. I know this. Deep rule, every block in Rust evaluates a value. If the last expression is semicolon, the block evaluates this thing. If it does not, the expression becomes return value. Now I test you. Will this compile and why? Will this compile? Yeah, it will not compile because it is not returning something called integer, because this is a statement, not an expression. So this is not getting returned. What is getting returned? The unit type, means this bracket. So yeah, it will not compile. It will throw an error. Uh, this will this will I guess compile, because we are not defining what is the type of return. So I guess this will compile fine. Why does this work? Oh, let's see if this works or not. We have not seen yet if this works. Yeah. We got this. This is unit type. Important. This is the unit type. And why this works? Because this works. It's the same. Instead of, saying return zero, we can say return nothing. Like return zero was the name of function. Instead, we just name it shortly f. And instead of this whole drama, we just write f. And since this is a function, we use this. Doing the same thing, explain it in your words, own words. I will do it, but for now, we'll move forward with the docs and the prediction. What happens here? Let's predict. What happens here? This is a main. It makes a immutable, since by default you make a variable, it's immutable, which is a value 5, but it is in a scope, and it returns void because this is a statement. So what we'll get is this. We'll get a void type. That's what we shall get. Let's do it, shall we? If our prediction is correct, the output will not change. Be our prediction correct? Let be our prediction. Yeah, our prediction was correct. So we get a unit type. That's what I wanted to show. Now we have shown. So instead of answering this, instead of answering it, I will just move on with the docs, because we are learning more with docs. And we were understanding that code. We move forwarded from our docs. Yeah, we shall move to the next chapter. Now debug. Rust, for example, the next topic is debug. Let's see where we have reached for now. Okay, not this. I want this. So we have seen hello world, then comment, and then 1.2 formatted print. Inside this, we are in a debug. Then we'll see display, then we'll see formatting. All right, good for us. So debug. All types which want to use standard FMT formatting trait requires a implementation to be printable. Automatic implementations are only provided for types such as standard library. All others must be manually implemented somehow. All right. All types which want to use standard FMT formatting traits requires an implementation to be printable. Automatic implementations are only provided for the type as in the standard library. All other must be manually implemented somehow. The FMT, this colon colon debug trait makes this very straightforward. All types can derive automatically, like create the FMT debug implementation. This is not true for FMT display, which must be manually implemented. I don't know what it is trying to say right now, but there is something like FMT debug and there is something like FMT display. FMT display was something that we used in println. Remember that? And after using println, if we use this, error thing, I guess we use the FMT debug instead of FMT display in the macro. So first, let's see what it's trying to say. This structure cannot be printed with either with FMT display or with FMT debug. Why? Because I32 is a type, but we are sending it in a place of input. So I don't know what we'll get. We'll not get anything. This is unprintable. So the derived attribute automatically creates the implementation required to make this struct printable with FMT debug. So this will now print a debug printable. All right, let's try to do it. We'll get a lots of error right now. So no input because of this, I guess. But if we just, comment it out. Oh, damn. I want to type on this thing here. Can I not just type? Yeah, now I can just type it. Oh, damn. I want to type this here. We can type here. It's telling me we can't type here. What the hell? Oh, all right. So we can't edit it here. We'll just copy it. This is a 3. So we'll remove every sort of binaries. That is 2.rs. No, 2.rs. No, 2/1. 2/1. Yeah. Now we'll create nvim 3.rs. We'll try to print this. Just C 3.rs. We got a 3.rs by default, and there is no output. All right. And instead of, shall we comment it and try it again? Will it give us a debug? Oh, it didn't give us anything. Wow. That's what it's trying to say, that there is no output. All right. We will not get any output. Oh, how can we? There was no println or something like that macro which can print out. So no output. All right. All standard library are automatically printable. All standard library are automatically printable with this too. It's telling me it's automatically printable. Derive the FMT debug implementation for structure called structure is a structure which contains a single ith. How many times have we used structure word right now? Derive the FMT debug formatting debug implementation for structure, full stop. Then structure is a structure which contains a single ith. Now this is something called derive debug, and put a structure inside the structure deep, make it printable also. So we are putting structure in deep, and deep is also structure, and we will then try to print it. That's what it's trying to say. The main print ln this debugger and months in year 12. So it will print 12 months in a year. Let's copy this. And instead of doing all that, we instead of using nvim directly, I just used cat. Cat is a very good library for input and output. So here, oh, I can't scroll, but above I just printed out everything that was in 3.rs, but here I append, instead of appended, I write, like whatever was there in 3.rs got deleted, and I write it from start, the 3.rs, and I wrote this, and at the last line I pressed end of file, that is EOF. How to type this? In Linux there is control D. Control D is EOF. So if we have written C files with limitation that use this loop till EOF, then we have to press this control D to end that loop. So I know control D is end of file in Linux. As for, you know, Windows or Mac, I don't know if it's different or not. So I used end of file and then not appended. I write everything. But for appending, like if I wanted to append anything, I had to use double uh, this greater than sign. I don't want to though. Let's try appending it too. It seems nice. I appended. We'll see this in a different line. After pressing enter, we'll press Control D. Yeah, it got appended. Now let's open it using new vim, and we shall see that I appended instead of writing everything. But this was written and the previous code was deleted. So now we are seeing that derive the FMT, and we see that there is a structure which has I32 as an input, a single I32, and there is another structure called deep, which intakes this structure, which will have this I32. It's so damn, I don't want to say it, but yeah. Printing with this is a debugger with, is similar to this. This is just FMT display and this is FMT debug, I guess. All right. So this print ln month in a year, what shall it print? I don't know. So let's create this. And is not working right now. We'll try to print only the first println and let us compile it. Rust C, then 3.rs. Oh, oh. So the struct structure is never constructed. Note that warn dead code is a part of warn unused on by default. And the structure deep is never constructed. So two warnings have been omitted right now. Why the hell? I just want to see what this will print out. Let's see. So this will print out 12 months in a year. So why are we doing this in a debug mode or sort of whatever this is? And then the second println is, will take the first thing out of this index. So where is the comma? This is the first thing. After comma, this is 0 and this is 1 and this is 2 in index form. So it will take the first thing in a debug form. I don't know why it is in debug. I don't even know if this is a debug thing, but I have read it through somewhere. FMT debug, FMT display. So I guess this is debug and the normal one is display. So this will take Christian, and then second, this will take a 0 index, which is Slater, and is a actor name, which is actor S. No, it's actors. Actor S name, actors name. So Christian Slater is an actor's name. All right. And then this will now structure 3 will print, and we printed it. Yeah. And now deep structure 7 will print. Did we ruin something by commenting out these two things? I don't know. Let's see first of all what we get as an output. We got 3, so I guess it will run what we wanted it to. Yeah, 12 months in a year. But we also got this error that is warning us. It is not stopping us. It is warning us that the structure is never constructed a part of one unused on by default, and it is also not constructed. But let's see what it will give us when we try, when we just uncomment everything and try to print it. So let's dd and what tell, let's dd to and see what it does. Again we got the, I guess, same error. It is same error, but it is a warning, not an error. So I guess 3 will run normal, and structure 3 will print and deep structure 7 will print, and it got printed. I also want to do something which is destructive, but I want to, oh, okay, rather than destructing it whole, I just comment it out. Now it's showing me error, and let's see. First of all, let's remove the old 3 and now try compiling it. It's throwing me error, and it has not compiled because it's not a warning anymore. It's a error, and now we can't print that, print deep structure 7 will print and deep structure now structure 3 will print. We are not doing anything because it cannot find function a tuple struct or tuple variant called structure in this scope. And the second error is cannot find function tuple struct or tuple variant structure in this scope again. But it is also deep. So it is not even finding this tuple struct or tuple variant or function called deep in this scope because we have not even defined it. And if we define it, it is, I guess, what is it? It is some array, not this. dd and d goes 7 lines down and try dd again. Now it will compile, but will also throw an error. No, warning. It's an warning. And what is it that we are getting is field in this struct. This is a field in this struct. Help is that consider removing this field. If we remove it, then what else? Note structure has a derived implication, IMPL, implementation. Implementation for trade debug. But this is intentionally ignored during dead code analysis. Now it is telling me to note that one dead code is a part of one unused on by default, and the field 0 is never read. And help consider removing this field. And if we removed it, we get an error instead of just getting a warning. Now we have a 3 and it prints the same. And now we are getting this deep structure as printed and structure 3 as printed because it is defined, but we are also seeing these errors that are there. Help consider removing this field and note deep it has derived, I don't know, implementation, implication for the trait debug. But this is intentionally ignored during the dead code analysis. So because of, I guess, where is this? Because of this, this thing, it's, I guess, a note to it. If we comment this out, I guess it will now throw an error instead of just compiling it. Yeah, we got an error that aborting due to one previous error. What was it? We removed this. So it was deriving something called debug. Now we don't derive it, so yeah, we don't get it even. We are seeing some errors. Deep doesn't implement debug. So now this will not get printed because required by this formatting, which is something like this, is required by this for formatting parameters. And deep cannot be formatted using this because it doesn't implement debug. So to implement debug, we were using this. So this was an implementation sort of code which implements something. So I guess we have not too much deep dive into it. We just have seen this. We have it as in our back of our mind. Shall we move on? I guess so. And now it will just throw a soft warning at us and we can see our outputs. Yeah. Now, what is it? We have seen this, we have dealt with it. And now, so FMT debug definitely makes this printable, but sacrifices some elegance. Rust also provides pretty printing with debug. So instead of just using this debug, we will use hash, which will sort of pretty print this debug. So let's see what it does. First of all, this will pretty print this Peter, which is the struct person name and has an age. So this person, wait. Peter is not a person. This is storing the whole structure that's called person that has been passed with the name and age. And the name is Peter and the age is 27. So Peter gets this Peter variable sort of gets you know the address to this person structure and then prints that over here. And we are in pretty print, so that's why it does that. However, let's try removing that pretty out of the print. Let's see what it does. So it's not pretty after all. It's just giving us some, you know, not pretty JSON format. Let's make it pretty again. Now it's pretty again. And let's see. Oh, it's damn interesting. Let's copy it and let's save it over here. And then 3.1, I guess 3.1 would be appropriate. It's the same thing. And I want to know what it will do if we want to, pretty print this deep structure and structure also. So let's insert this pretty out of the print, pretty into the print, not out of. Yeah, so we have included this. Now let us try running Rust C on 3 on 3.rs. And now let's try this. Yeah, it pretty it pretty prints this structure called deep, which has a structure and which has an input of 7. It pretty prints it. Yeah, good for us. And before that, we had a structure which was taking an input. So now structure 3 will pretty print, not just print, it will pretty print. I'm enjoying it. I'm enjoying it. Now, Rust C, and we already got the input of output of this thing, but again we shall try it. 3.1, and yeah, we got what we actually got over there also. Now we shall remove 3 and 3_1. Now there is just code. So yes, you can manually implement display to control the display. Oh, tell me, please. Tell me how to do that. Oh, all right. So it told me that we can do that and we didn't do it. So what was the use of doing it? All right. So I guess we all understood what this sort of things does, and we understood what this print ln inside this, what is this question mark and this pretty print and print out of this. This is in debug mode.
This is debug, and this is debug but with a pretty print, I guess. FMT debug with a pretty print. Oh, it's elegant somehow. Yeah, it is not somehow. It is elegant. Now display. Yes, we are now at display. So see that display is something where we just use curly brackets instead of using that colon and question mark. So that's why it is display. Can we write something? No, we can't. We can't write anything. We can only see this or unsee this. Yeah, we can't edit this one, but can we edit? Yeah, we can edit the second one. So display. What is FMT debug? Hardly looks compact and clean, so it is often advantageous to customize the output appearance. Yeah, FMT debug hardly looks compact and clean. Yeah, it hardly does. So we often take advantage or to customize the. It is often advantageous. So we use FMT display to take advantage of it so that we can prettily print it. So advantageous customized to output appearance. This is done manually implementing FMT display, which uses only this, not question mark. The print marker. Implementing it looks like this. All right. So use standard FMT. All right. So import via use this FMT module to make it available. Then we define a structure which FMT display will be implemented. So this is now again a structure that we implemented back then too. But we had to use a flag of debug sort of, exclamation mark, nahi, that hashtag, and then define, then debug into that. Yeah, but here we are not seeing that. What I'm talking about is this. We had to do this over here. Somewhere structure. Yeah, we had to do this. But in the next one, we are not doing it because we are manually implementing that. So now to use this print marker, I will say it print marker because it says over here that this is a print marker. So I will say this as print marker, and I will say this, the question mark one, this one. I will say this as debug print marker. And for this, it is pretty print debug marker, whatever this is, pretty print. So to use the print marker, the trait FMT display must be implemented manually for the type. So we are manually implementing. So IMPL means implementation. So implementing FMT display for structure. So here is a type called structure, and we are manually implementing the FMT display for that structure because automatically it is not there, I guess. So we have to do this. Now this trait requires FMT with the exact signature. So function, we are defining function called FMT, and we are taking a self. It's looking like a class instead of just function. So we are taking self and self out of this, I guess. And then we have a F, which is defined as a, oh, I know this. This is a borrow, but it is of type mutable. So we can like write something if we want to and read something from it. It's read and writable, so it's mutable. What is mutable? We are taking the reference of FMT from FMT, the formatter. So we are taking the formatter that was by default there, and we are trying to do something with it. And this function is now defined. But what this one is saying that this function will return something that will be of type FMT result. All right, so I sort of understand this now, and we are now opening and closing this function to write something or implement this, what it's trying to say. Now write strictly the first element into the supplied output. So write strictly the first element into the supplied output. All right, cell.oh, I'd say. And then stream the F, it returns FMT result, which indicates whether the operation succeeded or failed. Note that the write uses syntax which is very similar to println. Yeah, I am seeing it. Write and then exclamation because it is a macro, and then F. Why F? Oh, F is this, I guess. So we are passing F, and then we are using this print. What was this? Print marker, and then we are passing this self dot zero. So zero is sort of an index of an array. In this case, it will be self and whatever the 0, 1 will be. I guess this thing. If there will be a structure 5, then it will print 5, I guess. Now let's see what it does. No output, I guess. No output, yes. Because we are not implementing print ln and whatnot. We are just using it. And shall we copy and paste it? I guess we will do this. So this is sort of a fourth type that I'm reading right now. So clear everything, and we'll create a fourth type as this is the basis where we are trying to do everything. And in the next one, I guess we will implement it and see the result, something like that. Let's try running it too. It will run. FMT display may be cleaner than FMT debug, but this presents a problem of the standard library. How should ambiguous types be displayed? So something that we are defining, which is sort of ambiguous, how should that be displayed? For example, if the standard library implemented a single style for all vectors of type T or input T, I don't know what T is here, what style should it be? Would it either be of these two, like vector, then path, and we have a path over here, and then splits on this marker. And then we have another thing that is vectors number, and which splits things on this thing, this comma. So 1, 2, 3. So it splits on this comma. Whereas on path, it splits on this colon. So it is asking, would it be either of these two? These two? No, because there is no ideal style for all types of the standard library, doesn't presume to dictate one. So FMT display is not implemented for vector or for any other generic containers, but FMT debug must then be used for these generic cases. Now this is not a problem though, because of any new container type which is not generic, FMT display can be implemented. Now we'll use, did it print something? Yeah, it did. So we are using standard FMT, again, importing FMT. Now a structure holding two numbers. So debug will be derived. So the result can be contrasted with display. All right. So we have derived debug so that we can contrast what display does and what debug does. So we are making a structure called minmax, which is a sort of debug, and then implement display for the minmax. We'll implement the display for minmax by fmt self. We are taking the self, which is the minmax self, and we have a f sort of marker, which f is sort of a variable. I can assume f is sort of variable which takes the, borrows the mutable fmt formatter again, and this function will return something of type fmt result. And now we are writing this function using write, and this exclamation shows that this is a macro, and we have this thing f over here, which is fmt formatter over here, and then we are defining these two in a bracket, that self.0 and self.1. Now we define a structure where fields are nameable for comparison. Like this will take a float of 64, this will take a float of 64, and this is a structure of 0.2d, and this is also derived debug. So to print this, we have to use question marks, colon question mark, or to pretty print it, colon hashtag question mark. Similarly, the implement displays for 0.2d. Now INPL, the FMT displays for 0.2d. What is this? So now we are creating another function called fmt, which takes the self, and then f is equals to, again, the mutable, uh, this fmt formatter, and then we will return this function's type as fmt result. Then we are writing the f, and x will be self.x, and y will be self.y, which is this. We are pointing to this. We are pointing to this point dot 2D, and in that class, sort of class, we are extracting this dot x and dot y. I don't have the terminologies for these things, but yeah, I understand sort of what it does. Customize, so only x and y are denoted, not the whole point 2D. Because normally, what will happen if we derive debug or sort of question mark, we'll just you know print the whole thing, like we did with the person, over here. We did with the person over here. We printed the whole person, and the name was as Peter and the age was 27, like this. Oh, come on. Yeah, name was Peter and age was 27. So instead of doing all these things, we are now using, Peter.name. What if we do it over here? Will it implement? No, because it is not sort of debuggable. Printer.name, Peter.name. You do this. Oh, it does. It does that. But instead of writing it on, println, we are making the custom sort of. I don't know if I have to, write 0, comma 1. Like the first one will have a 0 and the second one will have a 1. But let's assume that it also assumes what is written first shall be done first, and then later will be later. Not age. Age. It is of type U8. So U sort of, I don't know. U8 is, I've never heard. Did I execute? Peter and then age. We can also do this like 0 and then 1. I guess it will also do the same thing. Peter and the name. Peter is a string. This age is 27. Yeah, it also did this. If you want to reverse it, we have to explain what we are trying to say. 27 Peter. Now instead, if we just want 27, can we do this and still pass the Peter.name, or it is illegal? Oh no, let's first change it all. I want output as 27, but we are also passing Peter.name. So will it show an error? Yeah, it shows an error that arguments never used. So shall we delete it? I guess we shall, and it will automatically do this. Oh, now it has an error that why are we using 1? We shall either use 0 or we shall not use anything. Peter H. Okay, so not anything will not work. We have to say 0, 0. Will it print? It shall. Yeah, we got 27 points. Yeah, we understand something, that debug was not very formatable, but now we are implementing our own display for min-max, the structure min-max, and then the point 2D we are implementing for two things. So let's see. Okay. So we are displaying our own implementation of display of both minmax and point, and we are also printing the debug form of the minmax and point. So we'll have both of them, and we'll compare the structures. And let the big range of minmax be minus 300 to 300, and the small range of minmax be minus 3 to 3. What are we trying to do with this? I guess we are passing it to min-max. Yeah, we are I64, I64. So it takes two things. So min-max is taking the big range and small range. And let min-max over here is 0 to 14. So we'll see 0 to 14 over here. And then what we are trying to do is uh, the big range is big and the small range is small, and the small is over here, big is over here. And then point 2D is x 3.3, y 7.2, and then we are comparing this. But I guess what is the use of this? What's the use of this? Because it doesn't print in itself all, but let's see. I made it run, but it didn't, I guess. Yeah. Now we are comparing the structures for min-max first. So it is a display that we implemented of our min-max, and this is a debug form. We are seeing min-max and 14. So we are seeing the name also. If we wanted to pretty print, it will do min-max and the whole structure of this, we'll run it afterwards. But let's see the next thing. The big range is minus 300 to 300, and the small range is more minus 3 to 3. Okay, so it's just sort of not doing anything. Literally, it's not doing anything. It's just passing things and then storing it to big range. And if we want to print the big range, we have to implement it over here, big range, and then debuggable form. But for now, we are getting a normal display of the big. This big is getting a normal display. But if we want a debug display of this too, so we'll use this. Oh, we can't type question marks. I somehow forget this. In this window, we can't type question mark because as soon as we get a keyboard shortcut instead of just typing the damn question mark. So, all right, we'll avoid writing question mark over here. We'll use it in new vim to understand it more better. But for now, we can see that big range is getting printed as a normal display would, that we implemented as minus 300 to 300, which is showing the minimum to maximum range of it. And the small is also doing the same thing. It is using our own display. But if we do, colon and the question or this and question mark, we'll get a pretty print out of it. All right. And the next thing was, point. We also implemented its display on our own over here. So we are seeing the display as X is this, Y is this. So it is implementing like this. And here we can also do the same. Like first, we are sending the minimum, and last, the second one, we are sending the maximum. Let's assume that. Let me assume that we are doing this because here we are doing it. Like smaller range first and the larger range after that. It's a sort of standard mathematical notation if you used min max, arithmetic or integration and all that. So let me say this is min and colon. This is my display implementation, and let me say this is max. So we have now implemented or sort of edited the already display. So instead of getting, just the range, we'll get min is this and max is this, like over here. All right. But I guess there will be some, this thing. Uh, problem with this, I'm guessing yes. All right. So compare the points. Points is our own display is like this, and the debug display is like this. So debug display is not a very appeasing for normal people. They're like, what is these curly brackets? Why is it there? But it's not even that disturbing here. since it's implemented by default. So instead of writing our own display, we can use the debugs sort of display, FMT debug instead of using FMT display. It's I guess workable for me. It works for me. Now we shall also try 3D printing it again in debug. Let's run it. Oh, it didn't. Run it, run it. Yeah, it's running. Yeah, now we see now we see our own display that we edited as min is this, max is that. But since it's mathematical notation, we know that left one is always the minimum and right one is always the maximum. Or we can see using the number like 1 is minimum, then 14 is maximum. Here 0 is minimum, 14 is maximum. But debug display, we pretty printed it. Like we just added the hashtag. So we got this. And then the big range, it was already implemented. We did not do anything. No. Big range is also min and max. So we did this with min and max display of our own that we implemented. So we got this over here to min and max. And then points, we did not do anything except we added a pretty print of the debug form over here. So it is giving me a debug, which is pretty printable, I guess. Yeah, it looks nice. It's nice, I guess. So let's copy it and make it 4/4_1. Copy it and then 4_1.rs. Now rust C, and we want to run 4_1. 4_1. What we get is, so we get the same thing, but we can also make it however we want because it is our editor, IDE. So we did this with that, but I guess we should not. So let's clean 3 words and clean this too. Now there is no comma in between minimum and maximum, I guess. So if we do this again, our display will change because we changed it. Yeah, so there is no comma in between. So if there was not even the space, it will become 014, so it doesn't mean anything. So we don't want to do something bad. We'll just insert a comma here. And we get a real implementation of our display that works and works fine. And this looks fine too. And this is a mathematical notation, so we don't have to write min and max. It's not. But we now know how to edit or how to create our own display if we are not getting a display. And notice something that we have created our own structure. Like we have created our own structure, but we are now not getting, the warning signs because we have also created our own implementation of the display. So we are not getting that warning signs, which is good. Which is good. So what I wanted to do over here is I also wanted to show that this big range and small range, which is this, can also be written in a debug format. Like over here, we are using the min-max in a debug format. We can also write the big and small in that form if we want to, with a big slash, this hashtag and question mark. I was not able to do that in editor because as soon as I write those question marks, it sent me some errors. Let's do that and let's remove it from compare points. So X So now we get a pretty better in a debug mode. So this is not implementing by our own, display. It is using the debugs display, and that therefore we are seeing min, max, and then minus 300, 300. But over here we were using our own display, so we were just getting our own set of uh, display implementation that we just did. But here we are getting a debug sort of, and that too in a pretty print. So that's why it is like this. And again, min max like this. So let's sort of reset it, I guess. Where is this? Uh, so this is the default that is there. And now we understood what it meant. We tried editing it, and now we somehow get what it's trying to say. So the FMT display has been implemented, but FMT binary has not. Why do we need that? Why do we need that? Therefore, cannot be used. So FMT display has been implemented, but FMT binary has not. So therefore, we cannot be used as a standard FMT. Has such many traits and each require its own implementation. This is detailed further in as a standard FMT. All right, all right. So I don't think we should implement FMT binary right now because I don't know what is the first of all use case of that, and second of all, I don't know how to do that. I am a beginner. So yeah, activity is after checking the output of the above example that I did, use the point 2D struct as guide to add a complex structure to the example. When printed in the same way, output should be complex. Oh, so we are representing the complex numbers. All right, all right. So this is the real part of the number, and then this is the imaginary part of the number. So this is the real part, and this is imaginary part. Okay, okay. Now I understand. So we have to create our own sort of struct. What was the name of it? Complex. So we'll create our own struct complex. Let's do it. Let's do it. It's interesting. I am getting excited. I am getting excited. Let's do it. So display is will display also. We'll use this implementation of MMT display for our own complex, and then I guess use something like that because we don't know how to. Let's do it. Let's do it. Let's do it. I am getting excited. So we want the output to this. And bonus is that add space before plus or minus sign. Yeah. Otherwise, if we don't add some space, it will become something not very, you know, nice thing. So first of all, we'll just print using our debug formatter that we get, and then we'll try to implement it. But let's start. Hints in your case get stuck. Check the documentation. I won't need to check the documentation because I will check the the code above. All right, let's copy this because this is a problem set. So we'll just copy it, and we'll create a nvim 4 2, I guess 4 underscore 2. And since we are creating it, we have to write some. Oh, damn it. Insert mode. Now comment it out. Oh, we type what we want to do. So now we want to do this. First of all, we use imp. I don't know. Let's copy paste, but we'll understand it too. Use standard FMT. Sorry. Use we import standard and then colon FMT library that is there. This is our first thing. Now we create our own struct structure named as complex, what it will have, oh, structure complex, then what? Directly, all right, which will have, see, I'm getting some, recommendations. Real, which will be of type is equals to, or no, which will be of type F64 because it is a float and we want F64. We are getting recommendations, but do we want to use it? I guess so because we know what to do. Image, sorry, imaginary, so not image, but imaginary, img, and format again 64. Do we need to use comma over here too? I don't think so, but let's see. Yeah, it did use comma, so we should also. We did a spelling mistake, a typo, complex. All right, and we should also define sort of, derive debug. Uh, derive. Oh, sorry, derive. Then inside that debug. Is that it? Derive debug. So if we don't add this line, we can't print it and this format of question mark, print ln, and using those question marks. So this sort of helps us right now. Now we'll create a fn function called main. Oh damn, I can't use npr somehow. All right, we have main. Don't show me. So since I am getting some Copilot recommendation in NeoVim, and which I don't think I want it right now because I'm learning it. So let's do something. Let's use Vim. Yeah, this is the real code editor, the most primitive one. But it's advanced, but my configuration is very primitive. I keep it the minimum. And now what? Real. Oh, it's insert mode. Real is this main. In main, what I want to do? In main, first of all, I have to declare or use somewhere this complex like we used over here. In main, let min max is equals to this, and then we printed min max. All right. So we'll also implement let min, not min max, but let comp is equals to. All right. Comp looks like compare, but it's complex. So let comp is equals to become what? Let comp is equals to complex, and we will pass a real number, and then 7.2, let's say I. Is it all right? uh, I guess not. It uses curly bracket over here too, so we have to use curly brackets, curly brackets, and curly brackets. I guess this will work. All right, so we have our comp, and then we have not made our own FMT display. So let us use our debugs display. So we'll print ln, and inside that we will do what? We will first of all, uh, we will do what? We want a question mark or pretty print. Let's do just a debug, not pretty one, but a real one. And then we'll pass a comp. You know, will it do this? Let me shift this to something else. We also go there. 4. Leave the 3 one empty. 3 is empty now. 4, you go back there. And now, yeah. So I guess this will print. Is it fine? Or is there any error that we should keep in mind? Uh, println inside quotations, quotations. We are using debug, so let's say that we are using debugs. debug. This is a debug form. We'll implement display and then we'll use display. And then we directly pass the point over here, but we'll pass comp over there. And I guess this looks fine. This looks real. Now let's try to run, Rust C to see whether we did something useful with our time or not. Oh, damn. Missing IMAG and real. So do we have to instruct it that this is, oh, so we have to, sorry, 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 sorry. So what it's telling me is that, first of all, I have to do something like uh, real, oh, real, and then this is passed as real, and comma, and then imagery, imaginary, and then passing this. But imaginary is F64 or something else. Imaginary is F64 or something else. Because we are also using I. So I is not a part of F64. So we'll get that too. We'll get one more error. Let's see what it is. Yeah. Since it is float, we shall type this. Can real number be float like decimal number? Yeah. So it shall be 5.0 instead of 5. All right. What about the imaginary? Invalid suffix I. So I guess we will have to, use, what shall we use? We cannot use any number format. So I guess we have to use some string format. I'm guessing it. So the type that we have defined over here, what if we leave it empty? Yeah? Whatever type it is, just do it. And for the real part, we will make it like a float. Float means a decimal, so we'll make it like a decimal 5.0. I guess it should work now. No, it doesn't. It wants a type, it expects a type, or I guess expects just a colon. Nobody knows. It's 16. Ask for 16. J word append. Will it work fine? Oh. Expected a type. See, it's expecting a type. I don't know what type shall I put it over there. Valid suffixes are F32 and F64, but no, F64 was not taken as a real one. Let's do something like string. We are not getting any help. We are not getting any help. Let's append it to string string. How about that? Little. Ah, we didn't. Invalid suffix I. Why is it invalid here? Oh, first of all, we didn't use, semicolon. So we need that. Anything else, sir? Anything else? Now error is getting smaller. So first of all, use standard FMT. Warn the part is unused. Yeah, it was unused because we did not implement our own display for now because we want to just print it, yeah, in some debug format. But it's just a warning. But the error over here is this one. That suffix I for the float literal. Invalid suffix I. So how will we able to print just I after that? Let's use new. I think it will give us some, help over here. And instead of making it, string, what shall I make it? Give me some help, Newbim. It's not telling me. It's telling me F64. All right. But then real one is 5.0 and the imaginary one is this and tongue. How about just using it in how about this? Expected F64 found. So it found string. So let's make it a type of string. Can we? Array. Don't open it. Don't open. I don't want to. I want new. Give me some suggestions. So now it's not F64. So just keep this and how about just string? I don't want to use str because it's very complex, fairly complex, but let's just try. All right. Expected string found $str. So do not expect string. Let's make it str. Let's make it type of str. cd. Let's make it type of str. Do not expect anything else from us. But then there is no str defined. Shit. Expected a name lifetime partner. What you expected and what you not. How does it matter? So this will be the last problem that I'll solve over here. And after that, I'll just end the stream. I guess it's taking a damn too long. Will I have to go through this standard MD? I don't want to, but since it's telling me to go through that, let's try that. Again, I have to go read through all this. Hello, and there's plus, minus. Uh, what are we expecting to see over here? Oh, oh, oh. So if we are expecting, let's say plus, we'll add over here instead of adding over there. And if we are expecting minus, we'll add over here. So that's what it's telling me. Pretty print and debug format adds line breaking annotations. I want something, some data type that will help me over there. It's $E. What is doing? 1, 2, 3, 4, 5. But after 3, it's taking the 1, 2, 3, 4, 5 first of all, and then 0.1 means a floating digit after 1, which is 3. So after 3 digits, it point and then power of 4. Localization, syntax, or traits. There's iSize. What it does? Vector 2D iSize. What is iSize? Will it take anything? I will give it. Will it take anything? I will give it. All right, all right. Let's do it another way. So instead of just, typing this I myself, I'll just delete it. We'll just pass a float and we'll change this type to, F64. Simple F64. F64. No formatting right now. Zero formatting. Will it print? Ah. mm, Delete this. Delete this. Now, will it do what it must? Yeah, it is doing it. Now we are just getting a complaint because we are not using, first of all, standard FMT that we imported, and second of all, we are using debug mode. So yeah, fields in the structure, real, email, or whatever. What I want is to print what we got here, 4:2. It was free. So the real part is this, the complex part is this. But now I want to add, plus or minus, and let's try just adding plus or minus. We'll add, let's say, plus at first. Will it take it or will it show an error? It showed an error, I guess. Unexpected plus. So yeah, you have to decide on a different type that I don't know. It can be solved with just a type that will take plus, minus, and with an I. But is there any other way? Let me think. Let me think. It'll pass. First of all, uh, let's yank it first, and then delete and try something else. What shall we? Oh, don't print this. Yank this and print this. Sorry, sorry. I'm getting stupid right now. Yank this, print this. What I want to do is, let's say, comp dot real, and then comma, comp dot image. Let's create 0 I don't know if I should, remove the question mark properly or should not remove the question mark at all. Let's remove it over here. And any problem? I guess no. Yeah, it did print. And now I want the output. I'm getting 5.0 and 7.6. Nice, nice, nice. And let's do this. Uh, let's remove it. It's not needed. Um, Real is real, but for this, first of all, instead of writing it, this is, oh shit, I replaced it. R, not R. Insert mode REAL. Delete this. Yeah, comma. Since this is imaginary, IMAG. Imaginary is this. Give it a space. Give it a space. Now we have learned something called adding plus or minus. We learned it somewhere, no? We learned somewhere. Where is it? Where did we learn to add plus or minus? Oh, done. On the top, I guess. Plus minus 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 plus minus. Yeah, it does add plus. And then I over here. Yeah, we wanted this. We wanted this. Now it will add. Oh, sorry. Focus on that. Focus on that. Plus, and where's plus? Plus, and then I. Now I guess that I will see something happening real. Show me something I want. Yes. 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 I got it. I got it. I got it. Yeah. So it is still in a debug mode. Uh, let's now try to implement our own display so that when we just add, normal things like I want a display of mine. So let's print what I want. Print ln. What I want to do is if somebody, no, first of all, make it macro. If somebody was to just go like print my comp directly, like a variable, he or she may be able to just directly print it. But right now they can't. Let's try it because it will show an error because we have not defined our own. See, it is an error because there is no required formatting parameters by default. So we will therefore we were importing first of all standard formatter, and then we are implementing our own standard formatter for this stupid thing. But let's do it. How to do that? uh, the need for this is over. I want to see how to do this. So implement IMPL FMT display. So let's take a new line. IMPL FMT display. FMT display. Is this right? Implement FMT display. Oh, it's double golden. FMT display. All right, this is right. For complex. COMPLEX for complex. Oh, not like this, like this. And then what we'll do is we'll create a function called formatter. So FMT, we'll create a function FMT. See, it's telling me. And then yes, there is first of all self, 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 uh, only self. Yeah, only self. And then there is F, which takes ampersand mu, I guess, FMT display. No, FMT formatter, not display. FMT formatter. Why is it different color? Did I do something wrong? MUT FMT formatter. It's right. It's right. It's right. So I shall move on. And this function will return a type of FMT uh, double colon or semicolon, double colon, FMT result. And now let's implement, not by curly, by this circular bracket, by writing a write macro. WRITE. This is see, the print was the first macro, then print ln was the second one, then we used format. I guess we used format, or we didn't. I guess we did. We didn't use format. So let's take f first of all, and then we'll do something with it. What we'll do is, so instead of writing like this, we will write it in semicolons like this, and instead of writing you want it like real, real, and then we will give it something. Can we directly type it over here like comp dot real? If it does, it's nice. If it doesn't, we just follow along. And then comma, we needed comma now. We needed comma, and then imag, imag, and then we want to accomplish something like comp dot, you know, uh, what is it? What is it? IMAG image. And then the real portion was nice and good, but for the imaginary portion, we have to first of all add uh, where is the plus? The plus, and after that we have to oh, we have to add I for imaginary one, and this is our right. Shall we return it, or if we return it, we don't use semicolon. If we don't, we use semicolon. So did we use semicolon? No, we didn't. So this is getting returned. All right. And if this works, then it's all right, because instead of writing self.x, self.y, I've written self.x and self.y here. So let's see if that works for me. If it doesn't, we'll just make it like self.x, self.y. No problem. Yeah. We are getting damn too many errors that I can't even read. I don't want to read. Expected 0 generic arguments, and right is messed up. So let's check out. Right is messed up because of this, first of all. DD. Uh, is it good? Is it good now? Or we forget something. F and then real and image and then something else too. Uh, I guess a comma? No, we don't need a comma here. We don't need a comma right now. Shall we do it like this? Like this. First of all, GCC. Don't give me anything. Don't give me any gap right now. Let's see. Unclosed delimiter. Oh, why is it unclosed here? Close it. Oh, I removed that. Yeah, it's on me. So see. Result first of all didn't have this circular insert. It had these, and now I guess it looks nice. It looks fine. Yeah, and I guess it should work. If it doesn't, We'll do what needs to be done. Yeah, it doesn't. So it says right here that it wants something to look like this comp real. So we'll do that instead of writing it there. We'll write it where it's need to be. First of all, remove this 3 0. Ah, we'll use it in one, right? comp dot imag, and then write something like comp dot rel, which is 1, and let's make it 0. Now this shall work. This will work. No errors should be found now. If it does, I don't know what's messed up. Oh, damn. Comp.imag not found in the scope. Comp really is not. Damn it. Okay, so we have to take it using self. So first of all right, understood. Why is it not in the scope? Because yeah, let's append use self self dot com.real, and then here also self com.imag. Will it work? Damn, unknown field. Unknown field. Uh, yeah, comp is comp is not defined. Yeah, comp is defined in the main, and we are not in main. So yeah, it is not. It shall not be there. Self.x, so it's like point 2d dot x. So yeah, comp should not be there. Self.real and self.img. Now this should work. I think this will be the final. Yeah, it did work. Now we'll we got the result. Is it like what we wanted? Yeah, display, and then display should look like this. It shouldn't look like this. Let's go to this. We'll format it over here instead of GCC. We'll just say display comp, and it will not say real or complex. CW. It will just show me what's real, and like it shows the real number first, and then the imaginary the second or the third. What if I say or minus? Because I don't know what it is. Will it show plus or minus? I don't know. Yeah, this is a problem. We have not yet solved it, but yeah, we are not getting any error anymore. But there is a problem. What is the problem? Let's say imaginary is of type minus, and we are just hard coding it as plus or minus. So I think it's not a very good sign. We are not making much of a progress right here. But what can we do? Yeah, now we are getting the display as it wanted. Display, and then this. Let's make it real. Like insert display, and then this, and then debug this or this. This one should work, but doesn't. As for this one, shouldn't be there. Display complex will be debug complex, then real and integer. Yeah, see, imaginary number is taking plus or minus with itself, but I guess we can't pass it somehow. We are not able to because we have not determined the structure of what it shall be. We are just using F64, and F64 just uses float. But floats are also, negative also. But why can't we just use negative over here? Or can we use just directly negative? Shall it work? All right. So instead of passing 7.6, which is plus, let's try passing, minus 7.6 or 7.6. And I have no idea why it shouldn't work, but let's see. And instead of being over here, let's make it over here, display debug. And we have our own cell F64. Like float is also negative, positive, and in decimals, it should be there, yeah. That's good. Yeah, it did work. It did work. But since we have hard coded something, oh, we have not. We have not. We have not. But there was plus as hard coded over here. But uh, in the display, we are not seeing plus. We are seeing minus automatically. I guess this works fine. So why shall we even focus on what's happening, what's not happening? Uh, how about when I just remove everything, like remove this and remove that? What will it show me now? Oh, it does print. And then, yeah, so there's no problem as such that we are making so much. It, I just have to remove, the comma because there is no comma. Yeah. When we are writing a complex number, we don't use comma. We just remove this. And yeah, it's removed. Ah, it works. And it works as intended. So you see, this output is comparable to, the output over here. So I guess we did it. So 3.37 plus 7.2. And let's make that come true. So we have an implementation over here. First of all, we are doing this in comp, but what if we say that comp is mutable? Can we use comp again a second time? Let's try. Or I can just make it simple. But who needs simple here? See. And now I'm telling it to print. You notice. Now we have comp, but instead of passing 5 and 4 as a number, we'll pass something else. So replace 5 with 3 and replace 0 with 3. So 3.3 plus 7.21. So replace with plus 7 point, replace 2. That's it. And then 4.7 minus 2.3. 4 point replace 7 and is 2 is 3. Is that it? Yeah. Did it work? Did it work fine? Let's see. Done. Unexpected plus. So we don't pass plus. All right. We don't pass plus. We pass minus. We can pass minus. As plus, it's already understood. So we don't need plus. all right, we got it. We got it. So I guess we are seeing things for real, but over here we are not getting plus 7.2 as we are getting over here. But yeah, see this, this is 7.2. So we are not passing it in, the function of complex. We are just formatting it such that in our display, we are seeing plus if it's not even there. So let's do that. So let's do that by, what we are doing. We append a plus to it, and that's it. That's it. Yeah, it compiles. Now it'll work fine. Yeah, see? Now this is like exactly what it says. Not even a single number is changed. Debug, display. Yeah, fine. And what I was expecting was that, all right. So why, like this was a variable called compare, and then we were putting the structure complex, into that, and then we were using it. And then over here, we passed a different value of complex. So what if this is comparable, compare 1 and compare, let's say 2. Now these are two different ones. Now the scope is that I can't, no, I can do anything with this. I can do anything. There's no scope. No. I was just making things complex in my own mind, I guess. It works fine. It works fine. It works very fine. Yeah. So I guess we should move on. But this was not only interesting, this was mind-boggling for me. That if something is not made default, like something is not displayed by default, we can make something like display our own cells, that how we should display it, how we should not. Since it's written, and if we write something like, let's copy it, and let's, instead of writing this, let's write this. And now we, let's say, use a function called main, and we'll pass something like, uh, you know, let let y is equals to t is equals to, what is it? Structure. structure, structure. And then inside that, if we pass, 32, and that's it. No, not that, not that's it. We have to then print it. Print, print. First of all, we'll print it in display that we have explained over here. Display is like normal print. Oh, normal. Uh, and then we are passing t to it. That will do it. And then, oh, it's not print. This is print element. I am new to Rust, so it'll take time to, get used to it. And this will be a debug. 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 And how about just passing something like this? Instead of pretty like hash, I'll just use, oh damn, I have to copy question mark because I can't type question mark over here. Where can I get a question mark? Please give me a question mark. Please. Please give me a question mark. Damn it. All right. Let's go over here. Or just printing a question mark. Oh, Control plus C. Now just paste that question mark over here. Ah, I don't know, yeah. Because as soon as I press question mark, see what happens. So I don't want that to happen. So now let's pass T, but this is in a debug mode, this is in a display mode, and there is no semicolon. So add the semicolon to it. Yeah. Now try running it. Will it run? It should. What's the problem here? Nothing. Oh, it doesn't. Why? So it's saying, oh, there is no derived debug. Is there? No, there is no derived debug. So yeah, it will not work because we have to say derived debug. So we'll just comment it out. That's it. Yeah, there should not be any problem. We should write a derived debug over here. And we are seeing a display of 32 that we have passed. All right. So if we type, hashtag derived debug, hashtag brackets can is it derive or derive? Derive debug. Then semicolon. Does it need semicolon? I don't think so. Oh, first of all, uncomment this. Uncomment this. Control enter. Yeah, see, we are getting everything that we wanted. Let's save it too. It's interesting, so let's save it. How about 4 point? Oh, sorry. Uh, Control C. How about naming it Engine 4.2 or 4.3? 4.03. All right. O and 3 is 3 dot rs. Let's paste it. It's done. And then remove any binaries that there. 4.1 and 4.2. Ls. Yeah, there's no binary. All right. So this is done. Shall we move forward? Now this is test case. Oh, where have we proceeded to? Test case, and then when we move next, what will happen? We'll go into formatting. Display has, I don't know, display has test case. Is that it? Or do we need something else too? Like, let's move forward and then see if there is anything else. Yeah, then it moves to formatting, and after formatting, we shall go to primitives. Yeah, we'll go to primitives. Yeah. So now I understand. We haven't even completed the hello world right now. We are just saying hello to the Rust right now. And we haven't completed it. So it's embarrassing, but not as much. We are just new to it. Yeah. We have an excuse right now that we are new to Rust. But as soon as we get old with this language, I don't think we'll have that. Now test case list. So let me see something. I am seeing that if my live is still going on, or is it gone? See, I'm new to this live and all. Yeah, it's still going on. Yeah, it's still working, still going on. And yes, So this is test case list. So implementing FMT display for structure where elements must each be handled sequentially is tricky. So the problem that is that each write generates a FMT result. Properly handling of this requires dealing with all the results. Rust provides the question mark operator for exactly this purpose. Like using question mark on write looks like this. So we are writing write, but we are also adding question mark at the end of it. So try write to see if it errors. If it errors, returns the error, otherwise continue. All right. So I want to see this getting implemented with an error. So write question mark available implementing FMT display for a vec is straightforward. So we are creating a vec. Let's see the output, what we are getting right now. Then we'll read the program, what it says. 1, 2, 3. And we have a list, let v, and let v, then there is a structure called list, which takes vector and I32 as input with commas. Why is there an exclamation after that? This is vector, but what is this? I've never used vector in Rust, so I don't know how this works and whatnot. But we are still, something is not new to us. This is importing standard FMT. I know, normal. We have done this. We have done trucked, but list. Uh, we have used something like structure, and we use some define, and inside that we use structure. Use something same, but this vector is using this, angular brackets, and then passing I32. I32 is integer or 4 byte. Integer means plus and minus both. So yeah, it's not float, it's I32. Then we are implementing the display. We are trying to write. And for index v, we are doing something, then we are writing. And then in the main, we are just running this. So this all code is just the implementation of our display for the list structure. So let's see what our display is. So we are creating a function like always called FMT. We are passing self the whole class, I guess. And then the F is the mutable reference of the format for FMT formatter. And then we are saying that this will pass this FMT result. This will return the FMT result, this function, FN FMT. This function FMT will return the FMT result. All right. So now we extract the value using tuple indexing. All right. So vector might have multiple values, structure named list, and list containing a vector. And vector has like multiple elements passed as one. Wait a second. Like, let me, so I32. So it's like self.o. So if we passed only one element, it's self.o. Can we write? No, we can't write it away. I want to see the same thing, but I want to do something with that. Is there self.o? There is not. So let's take it. Let's take this structure and copy it. How about pasting it over here? We'll paste it over here. And then over here, we will create something for us. We will say, let's say x is equals to, what do we want? What is the name? Structure. 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 And then let's say we are passing 1. All right. Then, oh, we need this semicolon. And then what we are doing is printing the display of it. So print. We are not debugging because we'll have to define debug or something like that. Derive debug, not define debug. So print ln, creating a macro, and then just normally printing this variable. What's this? This is x. So you'll just print it. Will it run? Should run. Why will it not run? Yeah, so we are seeing 1. But what if we pass 1, comma 2, comma 3? What will it give us? So let's define the debug also. Let's derive the debug also. So do this, do this, do this, enter, do this, and debug, display debug, copy this. We'll just change the, you know, to x, and this x. Oh, damn. We'll remove this. Control enter is for run, control enter, run it fast, yeah, run it fast. Oh, damn. So, yeah, unexpected argument. So I'm getting unexpected argument about, 3. Uh, 1, 3. Why? Why are we getting that? Because we have not defined something. Uh, let's say this is 0. Then if we define, like, if we know we are going to pass only 3 elements, we can hard code it. So we are just hard coding it. And then here is 2. And then self.0 will pass at 0. Self.1 will get passed at 1. And self.2 will get passed at 2. Is there any problem? Playground time. Damn. So let's make it. Since it's 4 only, I'm just making 4. So 4.43. So m 4 dot rs, and then remove everything else. Like, yeah, delete 29J. We deleted everything. Not everything here. Uh, delete 26. See, it deleted everything. What the hell? Just delete 20J. Yeah. Oh, no, 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 no. Ah, yeah. We can do this. Now from here, delete everything. So delete what, 18, 20, 20K. Delete this, delete this. From here, delete how many? 5Ks. Using Vim is maths in itself. But is there any error? Is there any error that I don't think there is? There might be, but we don't know about it right now. So we use Rasp C and 4_4.rs. Ah, that's what I wanted. First of all, we are not able to scroll up. So let's see what it's telling me. So in structure, since it's only taking I32, what if it starts to take, multiple I32? Let's see. 4.2 नहीं यार, 4.2 नहीं, 4 or less. So let's just understand all the errors that we were getting. Oh, so I guess we can do this. We can't do this. So what we can is use a terminal that does that. So use just kitty, lead cd into project then into Rust, and into third day. Then what we'll do is try to running Rust C, and we'll run 4 RS. Now we can scroll and see all the errors. First error is no field on type, at ampersand structure. So cell.1 unknown field. All right. Cell.2 is also unknown field, and structure will not pass because it's only I32. So we have not even defined if there is cell.0, cell.1, cell.3. We're just doing it. That's why I don't use it in this way. It always shows some errors. Let's close it. .rs. There is. What if we do this? We implement 0, 9. We say 0 is of type I32. Then there is 1 which is of type I32. But we are then hard coding it. This is not a list because I don't know how to create a list in Rust. And 2 is I32. Will this create what we want to? Expected type. Let's see if there is any binary. No, there is not. So 0 expected type is what if instead of using these brackets, what if we replace it with these? I guess this will be some list bracket or something like that. Expected where this after struct name found this. So let's use the curly brackets. Replace it with curly and replace it with curly too. So I guess we don't know what to do. Let's move on with what's already been taught to us. Let's not jump forward too much like we tried to do. What I want to see is, will it take all these inputs and show it to me over here? Like this is doing something, but this is also for display that we are defining. This is also sort of uh, looping through the index and v, and then taking the elements one by one, 1, 2, 3, and then writing it out. So this works because there is a loop over here. But what if we try to do, let's try to do that also. Try it in debug mode. Determine. What is it? Determine or what is it? Uh, yeah, derive, not determine. See, there's too many things to learn. Derive. So let's do that. Hash derive, and then we pass display. What will we get? That's what I expect. Playground has timeout. No worries. No worries. No worries. I just overtime. Yeah, I can do that. I'll just copy it. And since it's new, I'll just create a 5.rs. And first of all, let's see what it does. Will it show me? So we'll get into insert mode. Yeah, will it show me the debug mode or will it not? Rust C, or will it show me an error? that we don't want. Yeah, we finally got an error. List cannot be formatted using, because it doesn't implement debug. Well, I did implement debug, so derive debug. Did I add? Oh, I added it here. I remember. But yeah, it is there. Derive display. Does it say derive display or what is this? I quit. It says derive debug, not display. Damn. It will take my life someday. Ah, let's try it again. Let's paste it and let's remove the older one. Why am I not getting an open line printed? No, no, I get it. Ah, now if I want to run 5, I get to see that 1, 2, 3. So debug is also sort of looping it through because it knows what to do. As for our own display implementation, we have to make it. Not 3D printed. 3D print is quite expensive here. Rust. Yes. So we are getting a list 1, 2, 3. What if we add more? What if we add, okay, so list is also a type. Like I can, is list a type or something else? Is vector a type or is list a type? I don't know. I I am guessing list is a structure that we are defining, whereas vector is something that is already there in Rust. So that's why it's already able to take or implement what was there. 6, 9, close it. Yeah, yeah. No. So what is it trying to teach me? It's trying to say, try this question mark. So try write exclamation to see if it errors. If it errors, then return the error. Otherwise, continue. So that's what it tries to say. Looks like this. So let's just copy it and paste it as you know instructions at the end of it. Yeah, I guess so. So you So now we know if we are implementing our own right, we can see the question mark and try doing it. But there is something more that is teaching me. See, we know how to form the function FMT. We know if what it returns a type that is FMT result. But we have not yet used a for loop in Rust, so we can see it over here. But first of all, let's start from here. So it first of all extracts the value using tuple indexing and creates the reference to a bec. So we have first of all created an immutable this variable called bec, which takes the reference of self.0. So there is no need for self.1, self.2, self.3 that I did over there. Self.0 is I guess taking the reference to this directly. What if there was another structure? Then I am guessing that it would be self.1. I have not yet implemented, so I don't know. But let's do it. What is the point of not doing it? You know, let's print. And instead of list, let this be structuri structure. Instead of vector, let's just remove this vector and this curly brackets. Now it will have an error, I guess. Oh, it doesn't work. First of all, it doesn't work at all. But it does says that, yeah, display. This is not. It should be debug. So let's make it debug. 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 All right. Then we want to see if this cell.0 is like this thing or this thing. If cell.0 still goes to this thing, which it will go. Okay, oh, because FMT display for is list. So for is list. Oh shit. So yeah, every time we say cell.0, it will go and see for something called list, and it will take vector I32 as cell.list. Yes, that's why we are saying that vector is equal to, we are saying something like that. We are saying something like let vector is equals to v, and we are saying it to be this. That's what this line means. And then we are writing it as f and this, and question mark. So I don't think this is right. It just wants us to find out if this is right or not. So let's do it. So instead of, printing it in a debug mode or whatnot, let's just remove this first of all and try to, write it this way. Oh, so I see. So it's first of all taking a opening bracket and it is closing it over here, and whatever was there in between. Oh damn, so deep. Then I don't understand it. It will show multiple errors right now. This is results and this is lists. What is this for? So I guess there is one bracket extra. Yeah, that's what I. Yeah, shit. Remove this first of all. So it says FMT result, expected result, error implicitly returns. It returns what? Ah, it returns nothing. It returns nothing. Ah, now we see the error. Expected result, error found again. Okay. Try removing question mark. Try adding expression at the end of it. All right. The activity is try changing the program so that the index of each element in the vector is also printed. Try a new output as all right. So let's just do the activity first of all, instead of getting stuck into that. So we are opening a bracket for write, and we are then closing that bracket over here. And what we are doing in between is iterate over v, which is vector, v in vector. So we are taking v in vector while enumerating the iteration, that is index in index. All right. So for index comma v in vector, and we are iterating over it and then enumerating it for every element except the first, add a comma. and use question mark operator to return on the errors. So if index is not equal to 0, then write this, or else write this. Why is it like that? Because if it's 0, then don't use comma that we are using right now. But if it is like not 0, use a comma. And this will return any errors. This question mark will return any errors that we get in between. So this is nice. This is nice. And then we are doing what? Typing the V. So let's first of all run it so that we can. So if the index is not equal to 0, what can the index be? Index is not equal to 0. Then write this. And else we are writing this. We are passing V, that is the vector. How about if we pass the index also, index? And since vector was passing over here, we'll write it V, and we want index. So we want index to be over here, or not like this, curly brackets, index. Now let's see our results. Will it do what it wants to do, or will it not? So what are the errors? We're getting first of all V and index. So note that formatting specify whatever. We are getting an this can be removed. I guess we are not getting. Nice one. So what now? We have an index, no? So let's just try printing that index. Let's remove everything. Let's remove everything else. Let's try that index 0, 1, 2, 3. That's what we shall see. 0, 1, 2. Yeah, that's what we wanted. We are getting index. Now we want index plus this colon, and then something else. Yeah, so we are getting index and then colon and then something else. So what if we type index here instead of typing it over here? Will it do the same or will it throw an error? If it does throw an error, then what we did earlier was wrong. What we did earlier was wrong, but it doesn't throw an error. So what we'll do now here is we'll just type curly brackets and V. So will it show index plus vector both? Or will it not? It shows it. So let's use some random numbers instead of just 1, 2, 3 because it's confusing. 5, 2, not 2. Use 9 or something like something else. Just not what we expected. Show me, show me, show me. Arey, what the hell, yeah. It'll time out again. No, it did not. So 0 index is 5, 1 index is 8, and 2 index is 4. And we wanted it. So we did it. So here we go. We need to open up a Vim, a new Vim. So activity is done, I guess. And we finally wrote it. No, no. Instead of just copying and pasting it, try this activity uh, at our own. We can take help of this so that we know what we are writing. Because what's important is not just the activity, but also, you know, the practice of typing all those codes that are new for us right now. So we'll create a file one dot rs. Inside that, first of all, we have to import. So we'll how to import here. Yeah, we'll use standard FMT. Is it right or is it wrong? It is right. So next we'll move on to create a struct, that is structure. Uh, what we will be creating is not point. Uh, what we will be creating is list. So we'll create a structure called list. It will have a circular brackets. It will contain a vector that's already a data type, I guess. Uh, it will have a triangular or angular brackets which will contain I32, I32, and this will not end. This will start over here. No, this will end. This is our data type. And then we'll create a fn main which will run everything. So we will say let x is equals to what? Array, not lay. It's let. Uh, damn it. Yeah. We'll say let x is equals to, let's say, list, and then inside that we'll pass 1 2 3, 1 comma 2 comma 3. That's what we did, right? No, that's not what we did. uh, in list we have to pass a vector. See, no, vector is something that's predetermined. Then we passed 1 comma 2 comma 3, and it's done, I guess. Is it? Yeah, I think it's done. And then we'll try to print ln the macro. It will try to print normally because we will implement. Since we are not implementing it right now, let's just try debugging it. So we'll say this is debug mode, and is there something else we need? Yeah, we need to pass a variable that is x, not x, yeah. So I guess we are done. No, we have to define, derive, derive. We have to derive debug, first of all, debug, and then, oh shit, my IDE is constant. So I guess it'll work now. It just throw an error that we are not using standard FMT right now, but that's what we are doing. So let's run it. Rust C 5.1 RS. Yeah, see, we are getting a warning. So we still have a compiled version for this 5.1. So we are getting list as usual. Let's try pretty printing it. I'm very much interested in pretty printing. 1 2 3, and does it say something else? Oh. I was also thinking if our debug could also, give us the index and both. I don't care, right? I want to implement on my own. So let's copy this, yank, and paste. So one will become a display. So CW becomes display. Then instead of this debug, it will be a normal. And here we'll define our display. So implement, not define, implement our display. So we'll say IMPL and what? FMT, FMT, colon, display for list, for list. And then which bracket should use? Curly brackets will be used. We have curly brackets. Now what? We'll create a function called FMT. Function called FMT. This will take a value of self. What I remember is 10% self. Then it will take a format which will have ampersand mute formatter. No, FMT format. All right. FMT colon formatter. And then we just close this function. All right. Yeah. And then we pass a value that this function will return a return value of FMT result. That's what this function will do. And then we write this function. Is it right? Yeah, it's all right. So we'll start this by, yeah, declaring that vector is equal to ampersand self dot zero. All right. Semicolon or not? Yeah, there is semicolon. And then we'll say key write one, right? Please open up. So we'll say F, and then we will have this and open bracket, and at the end, also. At the end, we'll have a question mark. Where is question mark? Question mark. If there is any error, then return this. And not writer, it's write, an exclamation mark. WRI. Write, an exclamation mark. This is what we get. Is it right or wrong? It's right, not wrong. Now, for vector dot enumerate. Oh, what it is? No, this is not what I want. For index and v. So is there index that we have to define? So we have just defined it in sort of temporary manner. This is our index comma v, and for index comma v in vector dot iterate iterate over it and enumerate over it dot in num over it, and then we open up what we want to do with our for index. What we want to do inside a for loop is, first of all, if it is not zero, like it is not equal to zero, then we'll just write a comma, and if it is nine, if it is not equal to zero, we'll write a comma, and else we'll write whatever we want to write, index and vector. So let's do it. If index is not equal to 0, what we'll write is, should we would, yeah, so here I'm seeing that we shall use a new line. Let's take that, right? And question mark, where is question mark, semicolon. What we write is f comma, we write a comma, isn't it? So we write a comma. That's what we do. Yeah. And then what? Why is acha? All right. I thought why is there this bracket, but it is from this that we have over here. है ना? And if के बाद we have to just write WRITE exclamation mark ये and then question mark and semicolon at the end. Now we have to write over here. What we have to write is colon के अंदर index index. And then we have what is it? The value of it, and that's it. Yeah, that's it. And finally, we close this, right? We close this over here or after that? Yeah, we close this, right? WRIT. We close this, right? F, comma, uh, you know, closing bracket of square closing bracket, and question mark. No need for question mark here. And we are returning it, so yeah, no need for that. That's it. That's it, I guess. Yeah, simple. Well, not exactly simple, but yes, we got what we wanted. So thank you. 0, 5. So there's just one more space uh, like this. If you want to, just for a better formatting, we can just add a space for you. Oh, this is it. Yeah, it's formatted properly. Now just don't use this stylized or pretty debug. We just use a normal debug. And here we are. So yes, I think we can move on from this test case of list. I am going to take a break. So, I am going to take a break of, I don't know, 5 minutes. Let's take a break for 5 minutes. And till then, either you can read this formatting or I don't know, 3, 5, 5. Just So since we covered a lot today, so and my data is also getting finished, so I think I'll take a break. So I'll end the stream right now. We'll cover it, I guess, tomorrow. From we'll take it from this, what's the topic? Formatting. We'll take this forward from this formatting, or I guess just cover it up. Let's say tomorrow we'll take from primitives. So what is prompt formatting? We have seen formatting is specified by a format string. So format, let's say exclamation, it's also a macro, so is therefore there is an exclamation to it. So format exclamation, and then there is normal brackets, then foo, and foo is a variable which has a value of 3, 7, 3, 5, and so on. Now what format does is we can specify 0x for hexadecimal, and then we can convert our this number in hexadecimal using x, capital X, and then we'll get this hexadecimal value. Now format can also convert it into octal, so this is 0 and O instead of X, and then we are converting it to O, this number to octal. We have seen that. Same variable foo can be formatted differently depending on which argument type is used, X or O versus unspecified. So I guess this is unspecified. I know this is unspecified, and this is hexadecimal. This is O octal. So yeah, the functionality is implemented by a trait, and there is only one trait for each argument type. The most common. Wait a second. Wait a second. I'm getting my data finished, so therefore I'm getting too many messages. And the next time, we'll start this stream tomorrow, I guess, in the morning, I guess. Or we can also start at 12 o'clock if I'm alive. If I sleep through that, I started from 10. Wait a second. This activity. Let me see if I can get that up. So yes, I can claim data right now. So let's see this. Now we are also importing standard FMT as always, and we are also using this self, format, and display. So we are importing only formatter, display, and self. That's what this means, I guess. But let's read this. The formatting functionality is implemented by a trait, and there is one trait for each argument type. Most common formatting trait is display, which handles cases where the argument type is left unspecified, like this, for instances. So let's read it again. This formatting functionality is implemented by a trait. Trait is something, and there is one trait for each argument type. So there is one argument, there is one trait. There is another argument, there will be another trait. So one argument for each argument type. The most common formatting trait is display. Yeah, like this one, which handle cases where the argument type is left unspecified. Yeah, now it's not a guess. Now we know that this is unspecified, and this has a trait called display. So yes, we are importing self and formatter and then display. Display and formatter are traits, I guess. Display is a trait that we know for sure, and formatter is also a trait because it's alongside display. Now the struct city, we are constructing a structure. We are structuring a city, and it has a name which is a static stir, which is sort of a global, like literal, like it lives throughout the program. So when the program starts, it gets converted into binary, and we can read through it for the whole program till it's done. And as soon as it stops, the program stops, this thing gets dropped. So this thing will live throughout the program. So there is no, you know, that barrier of moving it or copying it. We can just use it. Then there is latitude in the city and there is longitude. Now we implement display for city like we always do, and we create a FMT function which will return FMT result. We take self, then F as mute formatter as we are taking from this, and the F is a buffer, and this method must write and formatted string to it. This method must write the formatted string into it. All right. So F is a buffer where we are writing this thing down. All right. So let latitude C is equals to self dot latitude from here, which is greater than equal to 0, 0. If it's less, then it's invalid. No, if it's less, then it's south. I'm sorry. Because if it's positive, it's north. If it's negative, it's south. And with longitude 2, if it's positive, it's east, else it's west. Right is like format. So right is like F, comma, and then uh, this is, you know, name, and then this is latitude with only 3 decimal places, and then this is either north or south. What is this? I know. Let's first of all run it, because lat.abs, what is abs? Where did this abs come from? Is abs something like abstract? Is it a function in Rust? Because I've never used it, so I guess it is. So what it will do is, I don't know. So first is name, second is this lat abs, which is absolute, or I don't know, doing something to it. And we need only 3 decimal places. And then this is either latitude C, which is either north or south from this thing, this logic we wrote. So this will be either north or south, depending on input. And here we are also putting the longitude with north or south from this program. And decimal places will be 3. We are writing it to the F buffer. Then we create a different structure which we have derived. No, we have derived debug. In this structure, we have not derived debug, so we cannot debug it using question marks. But this thing can be. We can only use a display, you know, unspecified bracket, which is just normal brackets. But here we are not since defining a display for this structure, so we are just using it as derived debug. So let's see what it's doing. In the main function, there is for city in these city names, and there's latitude for every city, and there's longitude for every city. And then we are looping through each city at a time. So we are taking city 1 first, and latitude and longitude. We are taking city 2 second, and then city 3 third. Oh, don't do this. Ah, and what it does is it we have already a structure, so it fills that structure with some data. We have 3 data right now, and then we will print ln and display the city. What this will do is display these cities for these loops. And the next is for color, in color red, green, or blue. Uh, this color will be red is 0, green is 3, blue is 254, and then the third color is this. So we are getting colors and we are getting our data for a city. So we now know the formatting. This is what we formatted our own selves, because we you know, implemented the display for the city. As for the colors, we did not. So we just used the derived debug over here. That's why we are using question marks. And for FMT display, switch to use this once you have added the implementation for FMT display. But since there is no implementation for FMT display, we can't switch to that. We can just delete this, and it will not give us any result because we have not FMT display for this. Now activity is add an implementation of the FMT display for the trade color. We will do that. two hints. There are two hints. All right, we don't need hints right now. You'll just try doing it. So what shall we do? Shall we take it in? Yeah, I think we'll take it in Rust. I mean, sorry, Newman. So clear it since it is 6.1. So we'll create a new. First of all, we'll create 6.1 where we'll just paste the Rust we got. And we'll not change anything over here. Then we'll create a 6.rs. It's easy to write 6rs than just underscore and do all that. Now for struct, we have to do what? We have to implement mpl impl implement display for color. It's color, isn't it? So let's see for city, and now we have a point of view what we can do. Is there anything wrong? Is there anything wrong with this? Implement color. All right. The second thing we want to do is let's yank it and wait. color. D, not D, X, color. We'll yank it, we'll paste it, and then we'll just use the unspecified CW. Unspecified means it will just print. There's so many errors that could go wrong right now. You also do not have this semicolon. No, I guess everything is right. color. All right. Now for we need, yeah. So for FMT, we are creating a function called FMT, and we are taking first of all self, which is ampersand self. Then we are taking F, which is taking a reference of, mutable reference of formatter, FORMATTER, and this is a function which will return FMT buffer, name FMT result, RESULT. F is a buffer, and FMT is a library that we are using right now. And then what? We have to write it. So what do we have? We have red, green, blue. And what's the format that we want it to be? We want it to be in format of RGB first. So let's create it. First of all, just write FMT, and then, oh, I am getting, recommendation from this, right? But we will not take it. We will do our own. Question mark is, if there are any results or any errors, just tell me. We'll take the FF buffer and we create this. Now, first of all, it will create RGB, and then it will show me the red, green, and blue. So now we want sort of 3 buckets, curly ones or normal ones. 3 like this. No, we need it in a circular bracket like this. And inside this, if there is any value, we'll have a comma, we'll have a comma, we'll have a comma. All right. And after that, do we need anything else? Oh, there is hexadecimal. So we are also getting a hexadecimal. Oh, damn. So I guess we have to analyze it also. We have to analyze and then create this. But how are we creating this hexadecimal? I have never created it. So let's see. First of all, before passing those hexadecimals around, let's just pass red, blue, and green. Is it red or self dot red? It's always self dot red. Self dot red, and then comma self dot green, and comma and self dot blue. Sorry, self dot blue. And let's create another variable. Let's call it what do we call it? Uh, let's call it hex code. Globally hex code, and we'll define that hex code over here. Hex code is equals to, so we are getting this recommendation and we will try it. So we'll format it, and format is a macro, and then inside a bracket we'll use quotes, and it is telling me to use hash, but why should I use hash? It is telling me to use hash. Shall I use it? I don't know. I guess I shall use the hash because we don't know how this goes. Like, how could we call? And second of all, we have not added another bracket over here, so it will throw an error anyways. Now it should not throw any sort of error. Not over here, but over here. All right. Now we have to create, uh, you know, square brackets. Inside that, inside that, I don't know. I have no idea right now. But I don't know why we add this, but let's do something like, let's do 2, 1, 2, 3, and comma. Not inside that, not inside. Here, comma. Again, self dot red, comma, self dot green, or self dot blue. This is something we can take. And now we are formatting what we want, X. So this is hexadecimal. You know, this will create hexadecimal, and this will also create hexadecimal. So I guess we have a hexadecimal, and we have a hex code for that. And will there be an error? There will be any error. I know that, RUSTC, because I think I have not implemented hex code properly. So yeah, see, self.green, instead we wrote cell green. So where is it? Cell green. Append self.green. Any other errors? Oh, not yet. I don't think so. Should it work? I guess. Why doesn't it work? I don't know. Oh, second of all, why are we using this, semicolon? Array, toolchain. This semicolon. We have to return this value, no? And let go of this question mark also. We don't know what it does. We have used it. Now hex code is not found. Why is it not found? Oh, we have not let array. Damn. This is basic. So this is basic, and we still haven't done this. So let hex code. Is it good? I think it should run. Yeah, it runs. Now 6 Yes, we get something. But it's not something that we want. It's something it gives us. So for colors, we only want colors. Let's remove this city, uh, and let's remove this structure city. So we delete how many lines? 20. 20J. Yeah. And inside this, we'll delete how many? 6. 8, 6. Okay. Now I guess we should see what we want to. So we are getting RBG, and this is something we are getting. Uh, the code is correct. I guess, yeah, this code is correct. This code is also correct. Uh, Not very much. And this code is 000. So we have to sort of format it. And this debug, we don't need it. So let's remove this debug code and let's format our, you know, let's format this. First of all, we need, can we add, array, damn. Can we add, can we add point 2 over here after this? Or do we have to do something else? And let's remove this, space. And before that, let's do 0, oh, 0 and X. I think yes. If point 2 works, then this code is running fine. If it doesn't, yeah, expected this in the format. All right. So this doesn't run because let's remove this. Let's remove it. Let's remove it. Let's remove it again. How about just adding X over here? X, X. It's small x. Will it worry this Rust? It doesn't worry this Rust. So let's see. Let's see. Damn, we got output. It just this is small x, so you know what we are getting. 0, 3. All right, all right. There is one more error. We need width also. So first of all, replace every x with capital X, and should we give it a width of 0? Uh, we also want, width of 2. So let's pass width is equals to 2 at the end. No, let's not do that. Let's just insert this and 2. Let's insert this and 2. And let's insert this. This works. This is fine. If it doesn't, Rust doesn't accept us. Ah, occur after this only. All right. So let's do that. What it expects us to do. First of all, let's remove everything. All right. And now let us insert it over here. 2, 2, and then 2. Will it accept it happily? Ah, it does. It does. So now it will work. So now we get exactly what we want. Do we? No, we don't. No, we don't. No, we don't. ATFF. The first one is correct. The first one is correct. The second one is exactly missing 1 0 with this pair and 1 with this 3 1. and this one is missing all the pairing zeros. This is not right for our program. So let's not give it a width of 2. No, we know something. We know something. We know something about it. Uh, we know something, but we've forgotten. Like, instead of using white space as the width, we can also use 1. So will, or should I include over here 0? We have studied it in width wala chapter. Let's see. Yeah, yeah, yeah. It does that. It does that. So thank God we know it, or else we would have been really in trouble. I don't really want to use a chat GPT right now, but yeah, if it didn't work, we had to use chat GPT. Now it works fine, I guess. Yeah, it works. So ATFF5A, and then this code, and then this code. Now we have made truly something that we like and we want. Like I always wanted to, see RGB and this hex code side by side. Now I can see it and I can do whatever I want. So I guess this activity is done, and you may need this. I never need this. So yes, it is also giving me hint. I, I didn't see that hint, but yeah. And for hexadecimal, you can use this 0 to x, but still it works for me. Bonus is that RGB R into 65 plus G into 256 plus B, where R is red, it is blue. The sign it can hold number up to 255. To cast U8, you can write variable name as U32. So if you would like to experiment typecasting in advance, so I don't know typecasting, so I can't, do it in advance. The formula for calculating a color in RGB space is something like this, but I don't know, so I won't be doing this bonus because later later. So we'll move forward with this and we land at primitive. But since I see that my data is getting finished, so I think I will end the stream now. So thank you for today.